Actually, I'm just going to sit down. Hi everyone. My name is Moritz. I'm a developer relations engineer at Affinity, and today I'm going to give a workshop on generating on-chain metadata and assets for Ethereum NFTs. And before we start with that, I have to go over some theoretical stuff first, so we make sure that we actually understand everything that we are going to build. So I'm going to give you a quick intro to the internet computer. Then we are going to talk about Canister smart contracts, their unique capabilities, and how we can use those capabilities to interact with Ethereum smart contracts. Okay. Throughout the slides, there are going to be a couple of QR codes that you can scan for further reading material, but you don't have to keep your phone out all the time. You could actually just scan this QR code once. That will lead you to the slides. I think the display should be my slides, right? Okay, perfect. You can just scan this QR code once to get to the slides, and then within the slides, you can just click on the QR code, and it will get you to the respective further reading material. So by now, a couple of you probably already have their first question, and that is, what is the internet computer, right? This is an Ethereum conference. What is the internet computer? So in one sentence, the internet computer is a decentralized and permissionless cloud built on blockchain technology. And before we start with the presentation, I quickly want to get a feeling of the room. So how many of you have heard of the internet computer before? Okay, awesome. And how many of you have built on the internet computer before? Okay, and how many of you are planning on building on the internet computer? Okay, yeah, maybe we can increase those numbers at the end of this workshop. Let's see. All right, so a permissionless cloud built on blockchain technology. Let's add a bit more context to that. So after Bitcoin, and there should be my slides. At least I'm seeing one on my screen. Also ich sehe hier eine Slide, aber da ist ja weiß, oder? Ja. Okay, weird. Glitch. Okay, sorry. Weiß nicht, was das gerade war. Okay, genau. Nach Bitcoin and Ethereum is the internet computer is a third-generation blockchain, and it solves problems that Ethereum has not solved with its evolutionary step. And that means that the internet computer is a high-performant, horizontally scalable blockchain that is able to run very general smart contracts and even host web pages. And I want to underline the statement a little bit by quickly comparing some of the key metrics between the internet computer and Ethereum. Let's start with the transactions per second here. IC is 2 orders of magnitude more performant, same for transaction finality. Transaction costs even more, and for the storage costs, again, even more, with it only costing $5 to store a gigabyte of data for a year. And while the internet computer excels in those metrics, of course, Ethereum is constantly improving through solutions like sharding and layer 2s. And another thing that is not on this table is that the Ethereum community is, of course, and the ecosystem is, of course, way bigger than that of the internet computer, and that Ethereum is a proven and trusted technology that has been around and used for many, many years now. And for the use case of today's workshop, we are going to combine the high-performance capabilities of the internet computer with the security and decentralization that Ethereum is known for. So with that out of the way, let's next talk about Canister smart contracts. So canisters combine code and state in one place. And when you want to deploy a canister, you first have to compile that canister from a high-level programming language, like Rust, for example, into a WASM module. And WebAssembly, or WASM, is a low-level and portable binary instruction format. And in theory, all languages that compile to WASM or that have an interpreter that can be compiled to WASM can be used to write canister smart contracts. And that includes Rust, which is what we are going to use today, or Go, C, C++, Motoko, JavaScript, Python, so many languages to choose from. Okay, so canisters are an evolution of smart contracts as you probably know them or think about them. And for us today, it's easier to think about them as decentralized server. So let's go over some of the unique features that canisters can offer that make them more similar to servers than traditional smart contracts. The first one here are timers. So canisters can automatically execute smart contract logic, either after a specified delay or periodically, so you don't need any off-chain infrastructure to do that. Then we also have the reverse gas model, which allows your users not to know anything about crypto, wallets, or tokens. And that works by pre-charging the canister with gas, and then the canister itself pays for the invoked computation. Canisters can also call into Web2 services, like, for example, an exchange rate API or an RPC node provider, or RPC provider for Ethereum. This is something that we are going to do later today. And yeah, this feature is called HTTP outcalls. And because canisters operate at web speed, users don't have to wait long for transactions to be finalized, and that offers them almost the same experience that they are used to from interacting with traditional Web2 services. The Internet computer also provides a secure and verifiable way to generate random numbers directly within smart contracts or canisters. And also, thanks to chain key signatures, canisters have control over a unique ECDSA key pair, and they're able to request signatures with the corresponding private key to be computed. And this enables canisters to natively hold, for example, Ethereum or Bitcoin or any other chain that supports ECDSA signatures, or tokens from chains that support ECDSA signatures. And we are planning on adding support for other signature schemes as well. Currently, we're working on threshold Schnorr signatures, and the plan is to release them by the end of the year. We talked about storage previously, but I didn't tell you how much you can store in a canister. So currently, you can store 400 gigabytes of data, with plans to enable terabytes in the future. And last but not least, canisters can serve websites and answer API requests over HTTP. And this makes it extremely easy for developers and applications to integrate with your canisters. And it also allows you to deploy your entire dApps infrastructure on-chain, so also the front end. So now that we know about the unique features, let's talk about how canisters can leverage those to interact with Ethereum. And with the HTTP outcall feature that I mentioned earlier, canisters can actually read state from Ethereum. And they do that by making an HTTP outcall to an RPC provider with their request. For example, they want to get the logs for an event. And the result is then becoming available in the context of the smart contract after the response is getting back. But they cannot only read Ethereum state, they can also write it. And that works by leveraging the chain key signatures that I mentioned earlier. So in this case, we're using a threshold ECDSA signature scheme. The canister creates a transaction, for example, using ethers RS or Alloy in Rust, and it then asks the threshold ECDSA scheme to create a signature on the transaction. And the signed transaction is then being sent to an RPC provider, again, using the HTTP outcalls feature. And for this, canisters on the IC can trustlessly interact with Ethereum. Okay, and because building a canister that securely and correctly interacts with Ethereum can be quite challenging, we actually provide the so-called EVM RPC canister for that. And this canister acts as a gateway to Ethereum and other EVM chains. It's basically a helper canister that does a lot of the heavy lifting for us, and it allows the developer to focus on the actual use case without having to replicate all the necessary logic to interact with Ethereum. And some of the things that Canister does is that it, for example, calls multiple RPC providers instead of only one, and it then checks that the responses coming back from the RPC providers are actually consistent, and this removes the risk of centralization if you only call a single RPC provider. And it also provides convenience methods that we can use without having to assemble the JSON payload first. And it also provides the responses coming back from the RPC provider encoded and candid, which is our interface description language. And that means that the response is immediately useful in the context of a canister without first having to deserialize it into something that we can use in the canister. So now that we have the theoretical knowledge we need, let's talk about what we want to build. And the project we are building today boils down to building a co-processor for Ethereum. So as you know, Ethereum smart contracts are pretty constrained computing environments, and co-processors enable to extend the capabilities of Ethereum by offloading specific tasks to a more powerful environment, and in that case, that more powerful environment is the internet computer. A co-processor could, for example, calculate some complex enumerable function or run some crypto like AES or RSA, or in our use case today, generate and store NFT assets and metadata. Let's go over a example flow. So it starts by the Ethereum smart contract signaling that it wants some co-processing to be done by emitting an event with the details about the job. The ICP co-processor Canister then regularly fetches logs from the contract using the EVM RPC provider, the EVM RPC Canister, and timers. And upon seeing a new job event, the Canister runs the requested job. And during the processing, the Canister can do many things. It could, for example, store data or make transactions to other chains, call other canisters, and so on and so on. So basically, a lot of freedom here. And if needed, the result can be written back to the Ethereum smart contract as well. And here again, we are going to create a contract call in the Canister, sign it with threshold ECTS A, and then send it to the network through the EVM RPC Canister. And in this callback function, we assert that the caller is actually the co-processing Canister to make sure that no one else is able to submit results that shouldn't be there. And because this co-processor architecture is very versatile and can be leveraged for a lot of different use cases, we actually provide a starter template for that, the so-called Chain Fusion starter. And here, of course, the co-processor logic is already implemented, and the developer only needs to worry about what computation they want to carry out in a job. And this starter template under the hood also uses the EVM RPC Canister to interact with Ethereum. And it comes with a dev container, which is basically a Docker image with all the dependencies pre-installed for minimal friction to start building right away. And this starter template is also what we are going to use as a starting point for today's workshop. So finally, what are we going to do? We are going to generate and store the metadata and the assets for an ERC-721 contract fully on-chain using the Internet Computer as a co-processor. Why are we doing this? Because generating assets and metadata off-chain bears the risk of rigged mints and centralization. Generating them on-chain is not really practical due to the extremely high cost associated with it. And storing them on IPFS doesn't really allow for dynamic NFTs in a decentralized way. So what we want to do is we want to enable fair and fully decentralized autonomous mints, and we also want to enable fully on-chain dynamic NFTs. And how are we doing that? We are going to start from the Chain Fusion starter template to then, on top of that, build a co-processing Canister that listens for mint events from an ERC-721 contract. And upon seeing such a mint event, that triggers the metadata and asset generation using the on-chain randomness provided by the IC. And this is the last slide. This is a sequence diagram to visualize the entire flow. I think this is very small, actually. But on the left-hand side, there is an ERC-721 contract deployed on Ethereum. On the right-hand side, we see the EVM RPC Canister and the Chain Fusion starter Canister deployed on the Internet Computer. And the sequence begins with the user minting an NFT on the ERC-721 contract, which emits a transfer or mint event. And as we already know by now, the Chain Fusion or co-processor in general regularly fetches the logs from the ERC-721 contract via the EVM RPC Canister and using timers. And then the Chain Fusion starter executes a so-called job for each mint event it sees. And in this case, the job is that we generate and store the assets and the metadata for the NFT using on-chain randomness provided by the Internet Computer. And because canisters can serve web, the assets, so both the metadata and the actual image, are available via HTTP after the generation immediately. And if we want to get to the URL that serves the metadata, we simply follow the URL returned by the token URI method on the ERC-721 contract. Okay, there should be QR codes here. Okay, now they're here. Yeah, so if you want to code along, scan the first QR code, which is the link to the starter repository that we are going to use. And because time is limited, I don't know if you are able to code along with me. Maybe it's a bit too quick. So on the bottom QR code is the outcome of today's workshop. So if you are behind or something, you can just copy-paste code over and maybe that way try and catch up. Okay, so let's head over to the repository. And the first thing we are going to do is that we are going to create a new repository off of that template. And I'm just going to call this workshop. And as soon as that one has been created, we are going to start one of those dev containers, or how GitHub calls them, code spaces. And we're actually going to click on those 3 dots here, and then we say new with options because we want a more beefy spec than the spec that it usually runs with. And I'm going to go for the 8-core, 32 gigabytes of RAM here. And I would suggest you to do the same. And while we are waiting for this to run, so this opens VS Code in your browser, but for some reason it doesn't really work for me, so I'm just going to connect with my local VS Code installation. You can do whatever you want, either use the one in the browser or your local installation. While that container spins up, we are quickly going to go through the existing infrastructure. So first there's this coprocessor smart contract that we basically went through in Ethereum. And as you can see, it has a function here called new job that is payable. So if you pay 0.0 Ether to it, it emits this new job event and it transfers the 0.0 Ether to the coprocessor contract Canister, so that that one can first of all pay for the computation and also pay for writing the result back to the smart contract. And to write back, we are going to use this callback function down here, and that checks that the sender of the message is the coprocessor to avoid anyone else writing results. And then we go into this Chain Fusion backend here, and in here we have our job module, and that contains the logic that is being run on each new job event that we are seeing. And this one is pretty simple. We basically just calculate the 20th Fibonacci number in this line, and then we are going to write that result back to the Ethereum contract, and that's it. And what we are going to do in this workshop is that we are going to replace the coprocessor contract with an ERC721 contract, and we are going to replace the job logic here with a logic that generates the metadata and the assets on-chain using the randomness provided by the IC. And what we are not going to do is we are not going to write anything back to Ethereum, so just this coprocessing as kind of like a side effect. Okay, so by now I think this should have spun up, so I'm going to click on the 3 dots again and then click on this Open Visual Studio Code, which will connect my local VS Code installation to this dev container. And the first thing we are going to do here is that we are going to replace the coprocessor smart contract with an Ethereum smart contract. And to get this Ethereum smart contract, you can go to book.getfoundry.sh, and then you go into chapter or section 24. And Foundry is basically the smart contract development toolchain we are using for our ETH contracts in this workshop. So once you are there, you scroll down a little bit. It's not the first implementation. It's actually the one here down at the bottom that says extending our NFT contract functionality and testing. We're simply going to copy this and paste it back into the coprocessor. And we are also going to rename it to nft.sol. And now there's a bug because the base contract, the ownable base contract, actually expects a constructor argument. So let's add that real quick down here. So we write in line 25 ownable, and then this contract should initially be owned by the sender of the message, so basically the deployer. And the next thing we are going to do is that we are going to modify the script that we are using to deploy this coprocessor locally, and now we are going to, of course, deploy our NFT smart contract. So we are going to modify the import up here. We can get rid of this argument that we are not needing anymore. We're going to rename this to NFT, this one to NFT as well. And here we're creating a new NFT contract. And now we have to also change our constructor arguments, and the smart contract expects a name, a symbol, and a base URI. So the name is going to be DappCon, the symbol is going to be DC, and the base URI This is actually a method that you can call on the smart contract called token URI. And what it does is it concatenates the base URI with the token to kind of form like a URL. And that URL usually points to a JSON file, and the JSON file is basically the metadata for the NFT. And as I said, canisters can serve web. So in our case, we are going to use a canister URL as a base URI. And that canister URL follows a certain schema. So it always starts with the canister ID, which is basically the contract address, followed by a domain name. And the domain name, because we run this locally, is localhost. And then we also have to specify the port that our local internet computer node runs on. So you can find the contract address or the canister ID if you go to dfx.json in the root folder. And then here it's the first canister basically defined, Chain Fusion backend, and this is the ID. So we're going to use HTTP canister ID .localhost and then colon 4943, 4943, and then a slash. And that's basically it. Now, we also want to mint a couple of NFTs when we deploy this. So we are going to rename this to NFT and then mint2, which is an argument that is exposed on the smart contract that expects an address to mint a token to. I'm just going to copy a random address from Etherscan to do that. So let's mint it to this address. And the value that we have to send along is 0.08 Ether because this is the mint price that the contract specifies. Okay, now we have the Ethereum smart contract implemented. Let's continue with the coprocessor. So for this, we go into source, Chain Fusion backend, again source, and then into the job module. And in here, we're going to get rid of the logic that currently exists. And we are also going to rename this new job event to mint event. And now we can get rid of this debug because we don't really need it. And yeah, the mint event is actually a transfer event, but we only listen for transfers from the 0 address. Thus, we are going to just call them mint events. And you can see the event structure if you go to the definition or the specification of ERC 721 and you search for transfer, you will find this entry here. So it has a basically 3 attributes, a from address, a to address, and then also the token ID. And in our use case, we only care about the token ID. So let's rename this to token ID. And now we have to modify this from method or function down here as well, because initially all the events that received by the canister are basically just, by the EVM RPC canister, are basically just generic logs, and we now have to convert the generic log entry to a mint event. And to do so, we need a token ID. And to get access to this token ID, we look at the topics field that each log entry has. So this is a vector of strings that you can see in the struct. And the first item of this topics field, so of that vector, is always the event signature. And that is a Ketchak 256 hash of the event name and the input argument types. And the rest of the items are indexed arguments of the event in order of their appearance. So all of the arguments here are indexed. So the item at index 1 would be from, index 2 would be to, and index 3 would be token ID. And that's why we are going to take the third, or the item at index number 3. And then, of course, we also have to rename this one to token ID and this one to token ID as well. Okay. This one is actually also a mint event. Okay, so the next thing is that we are going to get random bytes from the internet computer. And for that, we are defining a variable called random bytes. And that calls, or that is being filled by this method called random bytes. That is asynchronous, so we await it. And that's basically it. Now we have to implement random bytes. And random bytes gets random bytes from the system, basically. And it returns a 32 byte array. So an async function called get random bytes, takes no arguments, and returns a 32-byte array. And in here, this is a tuple what's being returned, so we destructure it, and we make a call to raw rand, which is an asynchronous method, so we await it, and it can fail, so we expect should not fail. And now we have to import this raw rand, and we import it from the IC-CDK, which is basically a Canister development kit, and this is the path I think VS Code takes that away from you if you're using VS Code, which we probably all do now. Okay, and now we have to convert this byte vector into a byte array. So we call raw rand and then try into, and then because this could fail again, we expect should not fail. This is of course not how you should do it, but yeah, for the sake of time. All right. So next we are going to seed a random number generator using those random bytes. And for this we are going to use charchar20 from seed, and the seed are the random bytes that we just obtained from the system. Okay, so now we have a random number generator seeded by the randomness provided by the system. And next, we are actually going to generate the first, or the attributes for our NFT. So let attributes, new variable, and we are going to call a function called generate attributes, and that takes a reference, mutable reference to the random number generator. So let's implement that method. First, we are going to add a new struct, the attributes struct, and that has two fields, a public background color, which is a string, and also a public circle color. So you maybe already have a little bit of an idea what this NFT is going to look like, which is also a string. Okay, now generate attributes. Oops. This takes a mutable reference to a random number generator, which is charchar20, and it returns the attributes struct. So we are just going to create this attributes literal in here, and we are going to say the background color is going to be the value of a function called to select value that takes a random number generator, and the same for the circle color, which is again a call to select value where we pass the random number generator. And now, of course, we have to implement select value. So let's implement that one. And this one takes, again, a mutable reference to the random number generator. And it returns a string, actually. So first we are going to, because our NFT is actually going to be an SVG, I didn't mention it yet, first we're going to define a couple of SVG color keywords. So we have an array here which contains a couple of keywords, color keywords, so we maybe have blue, red, and yellow, and green. And then we associate weights with those color keywords. So the higher the weight, the higher the probability that this specific color keyword is going to define either the background or the circle color for the respective NFT. And they are all going to have a weight of 3, except for green, which is going to have a weight of 1. So green is rarer than blue, red, and yellow. And now we are going to create a weighted index distribution. Oh, sorry, yeah, of course. Is that good? Or more? Yeah? Okay, sorry. I hope you could follow along still, kind of. Okay, weighted index. let's import this, and we are going to create a new one based off the weights that we specified, and we're going to unwrap this. And now we're going to actually select our color keyword by picking a random value from the array using the weighted index distribution and the random number generator. And because this is not a string yet, we have to convert this to a string. And now what's missing is that this sample here expects that you import this distribution from the rand crate. So we are doing that as well. Okay, now we have the attributes for our NFT. So we have a background color and a circle color. And the next step is that we want to generate and store the metadata for the NFT. This doesn't return anything, it just has a side effect. Generate and store metadata. And this takes a pointer to the mint event, or a reference to the mint event, and also a reference to the attributes. So let's implement this down here as well. Generate and store metadata. It takes a reference to a mint event and a reference to the attributes, and it returns nothing. So in here, we are going to create the JSON metadata using a library called SerDJSON. And then we are going to serialize that JSON into a byte vector variable that we call body. And to write JSON literals in our Rust code, we are going to use the JSON macro. So let's define the metadata variable here. Let's use the JSON macro. And let's write the metadata basically. So the first one is the name. The name is going to be a formatted string that consists of DappCon number, and in here in the parentheses we're going to insert the mint event and then the token ID. This is a typo, attributes, and this I have to import as well. Then we are going to also point to the actual image, which is the actual SVG that we are going to generate in the next step. And here again, we use the Canister URLs, right? So we are starting with HTTP. Then this is going to be our Canister ID, then localhost, and then 4943, which is the port that the local internet computer node runs on, and then this is the token ID, and the file type or the file ending is SVG. And now we have to fill in the curly braces here, and we are doing that by filling the first one in with the actual Canister ID, and I don't have to copy paste it because the ICCDK provides a method for me to get the ID of the contract that I'm executing this function in. And because this is not a text, I have to convert it into a text. And the other thing is, again, the token ID associated with the mint. All right, and now we're going to generate the attributes. So if you would trade or sell this token on OpenSea, you would have a nice representation of the attributes associated with the NFT, which is the background color and the circle color. And this is an array of objects that contain two keys or fields. The trade type, which for the first attribute is the background color, and then of course also the value associated with the trade type, which we are going to get from our attributes. And of course this is going to be the background color, and now I have to clone this as well. And now for the second one, I'm just going to copy paste this, and I'm going to rename the background color, of course, to circle color. And then down here again, I'm going to use circle color. So this is it. This is the metadata for our NFT that points to the actual image that is stored on the Canister as well, served via HTTP. All right, so I said we generate the metadata, but we also need to serialize it into a byte vector. And that's what we are going to do now. So we're going to create a new variable called body. And here we're going to use the toVec method that is exposed by 30JSON. We are going to pass a reference to the metadata in this. And then we are going to, because this can fail, expect that this should work. Of course, again, not best practice. All right. So to store our asset, to now later on surface it to the web, we use a method that is already provided with the starter template. And to be able to import this method into our job module, we have to first go back or go into the library module. And in here, all the way at the top, in line number 9, there's this mod storage that is currently commented out. So we are going to uncomment that. And now we have access to a method that is called store asset. And that accepts 2 arguments. The first one is the actual path that we want to serve the asset from. So let's define that one first. Because it's a metadata, it traditionally, for some reason, doesn't have a JSON file ending. It's just a token ID, and that's it. So yeah, in here, we are again going to format. And this is going to be simple because it's basically just going to be the token ID, and that's it. And in here, again, we use the mint event and the token ID. And for the actual asset, there's a struct that we are going to import that is coming from the storage module or crate. So let's import that. And now, basically write out the literal. This struct has 2 fields. The first one are the headers that we want to associate with the asset that we are going to serve. In here, we are only going to set the content type, which we're going to set to a text/JSON. And then also the body of the asset, which is the byte vector that we serialized in the step before. So let's start with the headers. And here we're going to use a vector. A header is always a tuple of 2 strings, the name of the header, which is content type, and then the actual value, which is text/JSON. And of course, both of these have to be strings. Okay, now we have the header. And the next step is to just use the body down here. And that's it. Now we generated and stored the metadata of the NFT, and we also made it available through HTTP. And the next step is that we are going to generate and store the actual image. And again, we are going to pass the mint event and the actual attributes to this method. Oh, that's wrong. Mint event and attributes. And in here, as I hinted and as the name also suggests, we are going to generate the actual SVG. And for this, we are going to make use of a crate called SVG to create the SVG, and then we're going to serialize that SVG into a byte vector again. So let's start with the background. We're going to use a rectangle node. I have to import this first from the SVG crate. So a new rectangle node, then we're going to set the width of that node to 100%. And we are also going to set the height of this to 100%. And we're going to fill it with the attribute that we generated for the background. So attributes and then background color. And again, we have to clone this. So that's all we need for the background. And now we're going to create a circle node as well. And again, we are going to import this node from the SVG crate. We're going to create a new one. We're going to set the center of the circle on the x-axis to 50, and the same thing for the y-axis. And then we're also going to set the radius of this to 48. And now, of course, we also have to fill this with the color. And in this case, this is, of course, not the background color, but the circle color. And now we have our background. On top of that, we have the circle. Now we can create the actual SVG document. And we are going to use the document expose by SVG, and we are going to set, I have to import this first. We are going to set the view box of this to 0, 0, 100, and 100. So this is basically a 100 times 100 pixel or dimension SVG. And now we're going to add the background to this, the background node, and then we are going to add the circle node. And for storing the actual asset, we are going to just copy and paste the store asset function from generate and store metadata and paste it up here. And the only thing we have to do is that we have to change the path. So this is not just a token ID, but it's the token ID.svg. And of course, before that, we have to serialize this into a body. So document, and then we do toString, and then into bytes. That should be sufficient. And the content type is, of course, not a text or JSON anymore. It's now an image, and in this case, a SVG. Yeah, now you generated your metadata, you generated your image, both using a random number generator that in the first place generated the attributes for the NFT. So that is basically all we wanted to do in our job. Now, I said a couple of times that canisters can expose data via HTTP, and to enable that, canisters have to expose a method, basically an entry point to the canister that is called HTTP request, and expects the system expects that this method takes an argument of type HTTP request and returns a HTTP response. So to enable our canister with this functionality, we are going into the lib.rs module, and we scroll all the way down, and then we uncomment this method that you find here, and we also have to import some of the missing types and the missing get assets function from the storage trait, which is basically retrieving the assets that we just previously stored, so the metadata and the actual SVG. And that's basically it with regards to the backend, with regards to building this coprocessor canister and building this ERC-721 contract. So the only thing left to do now is that we have to modify our deploy script, which basically deploys all of this locally and lets us see the result of what we just coded. So in here, so we use Anvil for our basically Ethereum network locally. That comes with Foundry and an RPC node built in. This is where we start Anvil. We need this caddy server, which is basically an HTTPS proxy, because otherwise the HTTP outcalls don't really work, so you don't really need to know about it, but that's just there for that reason. So after caddy start, we are going to insert the script that actually deploys the Ethereum smart contract, and we can go all the way down to the deploy script, and we can copy the last line and go back up and insert it after caddy start. And here we have to make a couple of changes. The first one is that the script is called nft.s.sol. We can keep this entry point. The fork URL is the same. We also want to broadcast all of the transactions, but we can remove this part after broadcast. So this now deploys our NFT contract locally and basically just runs the script that we defined here to also mint a number of NFTs so that we can emit events that we can then later on see using the coprocessor Canister. And another thing you have to do is that we have to modify the topics that we want to listen for. And we can do this down here where we deploy our coprocessor Canister or this chain fusion backend Canister. And previously we were listening for new job events, right, in the initial use case, but now we want to listen to or for transfer events. And as I mentioned, the first element of this topic is always the event signature, so a catch-up hash of the event name and the input argument types. So if we go back to the ERC721 contract standard, we can check this transfer event here, and we see that it consists of 3 attributes, again an address, and a uint 256. So all we have to do now is we look for a online tool to create a catch-up 256 hash, and we're going to pass in the name of the event and then the attribute types, which is address, and then uint 256. And we close the parentheses. And that's it. This is the event signature that we are going to pass. And now we listen for transfer events. Another thing we have to do is we have to add this 0x in front of this. But we don't want to listen to transfer events, right? We want to listen to mint events. So the second element of this topics that you can also, of the logs topics that you can also filter for is going to be this. Where is it? This from address, right? So, and we are specifying the 0 address as the from address, and that means that we are only seeing transfers from the 0 address, which are basically mints in most of the cases. So I'm just going to add a bunch of zeros here and copy paste them until we have the same amount. It looks good. And now we can get rid of this old code down here, so basically everything after sleep, or with everything after line 66 can be removed. And now we have our deploy script, and hopefully I didn't do any mistakes. Let me go back and scan over this real quick. So yeah, of course you can get rid of the imports that are not needed anymore to make everything nice and clean. So there's one thing, yeah, this one is not needed anymore. You could also delete this entire folder up here because it contains logic that we don't need anymore. And now let's try running the deploy script. So initially, like I said, we spin up this local Ethereum network. We then deploy our Ethereum smart contract, the ERC721 contract. Then we are going to mint 10 NFTs. And once all of those transactions are successful, we are then going to deploy the EVM RPC canister, which is basically this gateway canister. And this is happening here. And this boots up then, loading a bunch of stuff. Those are just like logs, right? If you deploy in mainnet, you wouldn't see that. And last but not least, we're going to deploy the Chain Fusion backend. And then the Chain Fusion backend, as you might remember, starts to fetch logs from the ERC721 contract that we deployed locally, and it fetches logs or events that are mint events. So there should be 10 of them that we should see. Okay, so there's calculate result. I think I just deleted that. So let's just rebuild. So while this is deploying, I can already talk a bit about what's going on next. So next, we're going to use cast, which is also coming with Foundry, and that allows us to make calls to the smart contract that we deployed locally. So we're going to use cast call. Then we are specifying what RPC we want to call. So dash dash RPC dash URL, and this equals to 127.0.0.1, and then the port that Anvil runs on is 8545, and then we have to specify the contract address that we want to call. So we can get that from the deploy script again. So it's this one here, because the deployment process already starts from the beginning. The contract address is deterministic, so I can just add it here and it doesn't change. And then we also have to specify what we want to call on this contract. And that is the, as I mentioned earlier, the token URI method. And that takes one argument, which is a uint256, and it returns a string. And now we also have to specify the token ID that we want to get the token URI for. Let's see. Submit result. Yeah, I should delete this and this one as well, of course. Weird that I didn't get any red squiggly lines, but as always, the compiler, luckily, is your friend. So yeah, this might take another minute. Sorry. But maybe I quickly summarize what we achieved. So again, we have this ERC-721 contract deployed locally, right? We mint 10 NFTs on it. Every mint emits an event. Then we also have this coprocessor canister deployed locally. This coprocessor canister listens for events on the ERC-721 contract. Every time it sees a mint event, it then generates, or first, let's go through the job actually. It first gets random bytes from the system. It uses the random bytes to see the random number generator. Then we use the random number generator to generate the attributes for the NFT. The attributes are the background color and the circle color. And then based on the attributes, we are generating and storing the metadata. We are generating and storing the image. And we are exposing both via HTTP. And if the demo gods are with me, this should run now. OK, yeah. So now our canister, the Chain Fusion backend canister, found logs to process. And for each log, which is basically a mint event, it's now running the logic that we defined in this job method here. So now I should be able to call the token URI method on the ERC-721 contract. If we remember, we passed in the canister URL as a base URI. This gets concatenated with the token ID. So we receive basically a URL back from this call. Let's try this. And this is this canister URL that should hopefully now point to the JSON that we generated. And luckily, it works. So as you can see, we have the attributes in here, the background color, the circle color, in this case, blue and red. We have a link to the image, which is again a canister URL, so this is also stored on the canister. And we have the name, which is DappCon1, because this is the first NFT that we minted. And if we now, for the sake of demonstration, let me just copy this, follow the actual image URL, you can see that this is the token or the NFT that we created. So the background color is blue as expected, circle color is red, so everything worked out. So one thing I didn't have the time to implement is this dynamic NFT claim that I made, right? I said that if you store them on IPFS, they are not really dynamic in a decentralized way. But if you think about the architecture that we built already, and we would imagine that on this ERC-721 contract, we expose another method that we maybe call reroll for the sake of the demonstration. And that method, if the owner like you pass in the token ID, and you have to be the owner of the token ID to call the method. And if you do that, that method emits maybe a reroll event. And then we can deploy our Chain Fusion canister in a way that it doesn't only listen for mint events, but it also listens for reroll events. And then in the job here, when we kind of like parse or convert the log entry into a mint event, we could also add like a a second case where it's a reroll event. And then depending on whether it's a mint event or a reroll event, you could have some custom logic in here. You could, for example, in the simplest case, in both cases, no matter if it's a mint event or a reroll event, you just execute the same logic. So you get random bytes again, you see the random number generator again, and you generate the attributes again. So basically, you give the user a reroll for their mint. And this is, fully decentralized. It's a dynamic NFT because not only the metadata changes, but also the asset change. There's no centralized infrastructure involved. Everything is running on two layer ones, basically the internet computer and Ethereum. And I know NFTs might not be as cool as they were a couple of years ago, but I think with this, there are a number of very nice use cases that open up. And because there are only 5 minutes left, let me quickly go back to the final slide here. So if you have questions, I'm around all day. So if there's anything that wasn't clear, I know this was a lot to take in, and I was pretty quick, and probably no one was able to follow along. But if you have any questions, you can ask me. And if you don't want to ask me, you can join the community Discord. So we have a Discord server with our developer community. You can also join our developer forum, where you can ask lengthy questions. And I'm pretty sure there are people either inside Affinity or outside Affinity that are more than happy to answer your questions. We also have a pretty big developer grants program. So we're allocating $200 million or Swiss francs for developers that are building cool things in the ecosystem. I'm part of the grants committee, so if you have questions about that, feel free to ask me. Then if you're still wondering what is the internet computer, there's a nice video series that we did together with Encode Club that you can find in this link. And then we also have a wiki page that kind of like shows the similarities and differences between the internet computer and Ethereum from the perspective of an Ethereum developer. And I think I have time I have 3 minutes roughly, so if anyone has a question that I can answer quickly, I'm more than happy to take it. If not, I'll let everything sink in for you. Did anyone follow along out of curiosity, or try to follow along? Yeah, and it was probably too quick, right?
Without coding, it's fine.
Oh, okay. Okay, awesome.
Can you show the QR code of the finished thing again?
Yeah, sure. Sorry. Yeah, it's here. There's also, I mean, this is basically the stripped down version that I try to fit into 45 minutes of live coding. So if you go to the Change Fusion starter repository and you scroll down, there's a more elaborate implementation of this all the way at the end. That's the same thing, but it does a couple of things differently, and it's like more realistic for a production environment, while this might lack. I mean, yeah, probably you want to have more than 2 attributes. Yeah.
Are there solutions to the developer experience? Because like it took 1 minute to like run the code again, which is not good to developer experience, I guess. Yeah, is it faster, or like is there a solution for that? Sorry. Okay. Okay. Yeah, so I was asking if there's a solution for the developer experience, because it took about 1 minute or something. Okay. Because it took about a minute or something to run the code, and this is quite a lot. So are there solutions to this problem?
I mean, like compiling the Rust code is inevitable, but because I compiled it the first time, or because this deploy script, because I compiled it the first time, it took longer. Like usually, I think there's some caching going on, and not everything has to be recompiled. So if I would run this again, it wouldn't take like that long, hopefully. But yeah, I think you always have to compile the Rust code into this WASM module. So yeah, that's probably something that can't be sped up or speed up. Sorry. Okay, then thank you everyone for attending. I appreciate your time, and like I said, if you have any questions, more than happy to answer them. Yeah, bye.
can go. Thank you.
Can you hear me? Yes. Hi, everyone. Nice to see so many people here. Excited to be here. My name is Daniel, and I'm the product lead for our new wallet, Metri. And this is Theo, tech lead in the Metri team. And today we will go through the wallet we're building, Metri. And can I get it up there? Yes, thank you. We'll talk about the wallet we're building, some of the technology we're basing it on, the mission, and functionality that we have in the wallet and that we will implement into the wallet as well. So let's kick it off. And we'll hopefully give a little demo. Hopefully that works as expected. It's always exciting to do live. But I would want to start by talking about our mission, because I think it's very fair to say that there are a lot of really good wallets out there. It's very tough market, but what we think has been missing for some time in the crypto industry is to make it more accessible to people. And what we're trying to achieve with Metri is really to give the financial freedom that self-custody enables to not just crypto native, but any person. So really make the barrier of self-custody lower than what it is today. And what we're aiming for is to give users a neobank-like experience, but with a on-chain self-custody wallet where they can send, receive, manage their assets just as easy as they do with any financial neobank or fintech app that they have today. And we're doing this by using as much as possible of what already exists there. So kind of build on top and definitely leveraging the Gnosis ecosystem as much as possible. So the Metri wallet is actually a safe wallet. We deploy a safe account, and that's the wallet, but where we have built a new UI app on top of this. But at its core, a Metri wallet is another safe account. And we're also working with other Gnosis products such as Gnosis Pay, Circles, and we'll integrate even more, but trying to reuse as much as possible to enable this neobank-like experience for a self-custody wallet. And now I'll hand over to Theo.
Yeah, just come here. Hi, yeah, I'm Theo, so I'm part of the tech team building Metri. So to get a bit more technical, we're building Metri as a progressive web app. Actually, I was curious, like, how many people are using progressive web app? Yeah. So I think it started to exist like a few years ago, and now it's getting more traction. But so the idea is just to have a web app that we can install on the home screen of your phone. And the good thing is that it's not, so it's like a web app, but it's going to show on your phone as a full screen, and it feels native. Actually, a friend of mine last week, I was showing him the app, and he was like asking me how we went through the App Store review, and I was like, no, it's a web app. Yeah. So that's why we're doing progressive web app. So it's like an app-like experience, but you don't go through the App Store. So it's, I don't know how many people here have tried to go through the App Store review when you're building crypto product, but yeah, that's a good thing that we don't have to do. And so it's just a web page, and you can install on your Android phone or iPhone. And yeah, I guess it's also like the web. We love the web, right? As crypto people, the permissionless version of the web. So we don't have to ask for permission to release new updates, and we can update also more often. And also might interest some of you, but we're building this app as a Svelte kit app, so it's a quite lightweight web app. We didn't choose like React or React Native. Svelte kit is quite good for PWA. I don't know if you used it before. And yeah, so Daniel mentioned we're building on top of the Gnosis Safe. So we are part of the account abstraction bandwagon. And but for us, what does it mean? Like, it means that we want to provide like Web 2-like experience, but for Web 3. And there's three aspects. So the first one is around security, safety. So in Web 2, if you lose your password, as you know, as it's very common, you have the I forgot my password link, and you can get a new one. And with the safe, with account abstraction, you can do that, right? Because you have multiple owners of the safe, so you can replace one with a guardian or recovery system. So that's one thing. Second one is around fees. So yeah, caveat, we're on Gnosis chain, so at the moment the fees are quite below 1 cent, so we are sponsoring all transactions, most of the transactions. But yeah, the joke is that, you know, when you're using Web 2 product, you're not paying for the AWS fees every time you're posting on Instagram or whatever. And so with also account abstraction, Gnosis Safe, we can do that. We relaying transactions. And the last one is around batching. So one transaction can actually include many transactions, which is something very useful in crypto, obviously, because, I don't know, if you're swapping, you want to approve the token allowance and then swap. So yeah, batching transactions. And we think that now the time actually is right. I've been saying that for 5 years because I was building wallets before, but I think that now the time is right, like, to actually bring more people on chain and to have an experience that can be better than Web 2. And one why I can say that is because we're using passkeys for key management, and we think that's actually way better than what's provided, like what was Web 2. But actually, Web 2 now is bringing passkeys. But so, what are passkeys? It's a standard that's supported by Apple, Google, and it's giving users private and public keys, so they can sign messages with their biometrics, so Face ID, Touch ID, and they don't need password anymore. So, you know, we dislike passwords, I think. We know why, and so with Passkey you don't need password anymore, which is really good. And for us in crypto, it means also that we don't need seed phrases anymore, which is even better because seed phrases, right? And for that, we partnering with Commerce. Actually, the Commerce team is owning this corner. You can talk to them afterwards. They're friendly people. And so what they're doing for us, like when a user is signing up on Metri, they create a passkey. The passkey is a public-private key, and Commerce is going to deploy a safe with one owner, and this owner is a contract that's able to verify signature from this passkey. Because it would have been too easy if we could just have verified directly, but the elliptic curve of the passkeys are different than the Ethereum one, so we need some crypto wizardry, but cryptography wizardry. But yeah, it's working. So basically, I sign a message with my passkey. I send it to the safe. The safe is going to ask the Commerce contract if it's valid signature, and then the transaction can be executed. And you see that during the demo if that works. One thing you might ask is like, well, okay, it's really, really nice, but what happens if I lose my device, if I lose my passkey? And that's for Daniel to answer that.
Yes, thanks, Theo. So yeah, when it comes to recovery, there's multiple ways of making sure that you have access to your funds within Metri. But as the primary way of signing transactions in Metri, we do use passkeys. So that's the key that you can use natively in the wallet. You have one passkey when you deploy and create a new wallet, but on top of that, you can also create additional passkeys on other devices or other password managers that you can add as an owner to the safe account that we deploy. This could be a good way to just like lowering the risk of you losing your assets. You can have one on your iPhone, one on your Android device, for example. And they can typically be stored, backed up in the cloud if you on your device have that enabled. So on keychain for Apple, for example, and then you can just log in from any of your Apple devices and you'll be able to sign with the same passkey. But the passkey is tied to that Apple ID, so there's no way of someone like stealing your passkey and then able to use it like from some phishing or something like that. So the passkeys in itself makes it quite easy for you to keep access to your wallet, having them backed up, and you can have them on multiple devices, and they'll just be added on your safe as owners. But we will, in addition to this, add the ability for you to add any Ethereum wallet as a guardian on your safe account. And this will be very much just leveraging what's out there. So again, trying to reuse as much as possible from the Gnosis ecosystem and any open protocol that is out there for that matter. But then you'll be able to add any wallet to your Metri wallet that can do recovery of your wallet with a time delay. So you would have to initiate a recovery period, and when the time delay is over, you can add new owners to the Metri wallet, and in that way get back access to your wallet. And we will also use built-in functionality from the wallet, such as circles, where you already building your trust network. Not sure of how many of you are familiar with Circles and tried it before, but with Circles, we're building this on-chain social graph. So where you trust someone means that you can interact with them and you can pay Circles peer-to-peer. And we're also adding this trust element to Metri so that you can do recovery of the contacts that you already trust as part of the Circles network. And this is, really to make sure that risk of you losing your assets, access to your wallet is as low as possible. But also, in the end, it is a self-custody wallet. There's no, forgot my password. Can you please reset my account? But this is what I think is a really good setup for you to make sure that you get access to your assets and your wallet with multiple options of backing it up, both with passkeys and normal Ethereum wallet addresses.
Yeah.
Please. Yes, and I did mention it before, but Circles is one of the core products and protocols that we have integrated into Metri. So there are Circles people around and also downstairs, which knows Circles really well. And Martin's going to do a speech on Circles on Thursday, I'm pretty sure it is. So you should definitely go and listen to that one. It's very exciting, and Circles are doing some big updates this summer. So be a lot of interesting, exciting announcements there. But with Metri, come back to Metri. You can import an existing Circles account if you have that. So some of you might be familiar with Gnosis Garden, which Martin also mentioned this morning. And if you have a Gnosis Garden account, you can import that to Metri. And what we do then is that we actually not deploying out a new safe account, we're just taking an owner and adding it to the existing safe account that was deployed when you created your Circles Garden account. And that owner will now, together with the other externally owned account owner, be the two owners of your safe account. And with this new owner, you can now use your Circles account within Metri. So you can sign transactions, you can add owners, manage that, and you can also trust and untrust Circles contact to build and manage your Circles network. Next one. And yes, Gnosis Pay. again, trying to use what's out there, Gnosis, in the Gnosis ecosystem. And Gnosis Pay is a very, very interesting product that's been getting quite a lot of attention lately. And as you probably know, it enables you to have a self-custody account where you can spend with a Visa card without having a bank account in the background. So you can spend at any merchant that accepts Visa cards using Gnosis Pay and the Gnosis card. And with Metri, you can get a mobile-first kind of dashboard or at least interface of your Gnosis Pay account. So what you do in Metri is that you can toggle over to the Gnosis Pay tab, and from there you can connect your Gnosis Safe from Gnosis Pay, connect that, and then you will have that the balance of that account and all the transactions that you've done on that account displayed within Metri. So for the first time, you get like a mobile-first UI of Gnosis Pay. So it's, in this first version, a quite lightweight integration where you track that wallet, but we will add more functionality there. So you can have sign in with Ethereum, and where you can then read more data from Gnosis Pay when you authenticate it. So read like merchant names and do transaction from the Gnosis Pay account. But already now you can see the balance, you can see transactions, and you can top up your Gnosis Pay card from the Metri wallet. So it's it's an easy way of managing your Gnosis Pay card already, and we will add even more functionality there in the future to make it a an even better integrated product into Metri. And then what's next for Metri? So there's a lot of great ideas out there, and I've been talking to people downstairs, having all kind of ideas of what to do next. But we definitely have some very good contenders where we will add functionality to Metri. And a first one that is pretty obvious to us is to add genome to Metri, because going back to the first slide there, is what we're trying to do is to really make this technology accessible to everyone and make the user experience as smooth as possible, more Web 2-like experiences. And on-chain addresses, they are not the easiest to read and to follow. So adding a genome functionality where you can get your .gno address is definitely something that we want to add, and we want to integrate it into the wallet so that you easily can register a .gno domain, and you can also manage that within the wallet. You can send to that address, you can share it to others. So that is something that we will make sure to have nicely integrated into the wallet. On top of that, we will also look at getting an easy way for people to access yields. So we have an SDAI integration that we definitely want to do, where a user should be able to convert their XDAI to SDAI. And if you're familiar with SDAI, that's an interest yielding token that is getting the yield from the bridged asset from Ethereum. So this is a very good yield. I'm not sure what the latest is, but it's a very good yield, way better than you get from most other TradFi saving solutions. And this is a yield that you can then get and then easily swap back and forth with the COW protocol as well that we want to integrate. And there are two ways of getting XDAI. You can convert it or you can deposit it. But we want to start by doing the deposit one, but then also enable COW protocol because we do want to make it as easy as possible for people to move between different tokens, and COW protocol enables that with their SDK, so we can integrate that natively into the wallet. So that will make it easier to swap, and also if you want to top up and fund your Gnosis Pay account, you can easily do that via CowSwap, where you can set the deposit address to either Metri wallet or to the Gnosis Pay account, and you could then top up in EUROE or GBPE if you have a GBP account, and in that way make the interaction between Gnosis Pay and Metri even better.
Oh.
And now I'm going to show, maybe some of you have already tried this, but let's see if I can show what it looks like. Is that big enough? Can you see that? Let's do this. So I'll do it all the way from the beginning. So this is
Not running.
yeah, maybe we jinxed this. Yep.
Yeah,
I think we
it's
did.
gone.
Is it slow Wi-Fi or? Oh, okay, yeah.
Okay.
Now this works at least. Yeah, so this is just the start screen where you onboard. You could either create a brand new wallet here. You can import a Circles Garden account if you have that and you have your 24 words. You can import that. Or you can log in or import a already created Metri account. So I'll go ahead with this one, and I'm going to use my keychain passkey. So there, logging in with my biometrics, and here it is. So this is my Metri wallet. And as I mentioned before, and Theo as well, when we create a Metri wallet, we deploy a safe. So this is actually the safe account that was deployed when my wallet was created. Standard QR code that you can use to share it, and these are the tokens we support. And we try to keep it quite narrow focus on payments, so it's mostly stable coins, but also circles that you can manage within Metri. I'll remove this, and here I can mint circles. So circles is a UBI where you get about 24 circles every day. So now I have some circles that I haven't minted in a while. I can then mint circles. I sign again with the passkey, and there's a new transaction coming up here. And the dashboard, it's pretty straightforward dashboard, but again, we're really trying to keep it as simple as possible. And keeping it similar to what you could expect to see from a neobank like Revolut or something. So this is how we built it and the design that we're using. And I was also going to show how you can. Okay, I didn't have any. Oh yeah, that's because I swapped. Sorry. Messed up. But as I said, you can add your Gnosis Pay card. So I'll do that. You swap over to the Gnosis Pay tab. You could either initiate to get a card if you don't have one, or you can connect an existing one. So now I just need to get my wallet address for my Gnosis Safe or my safe for the Gnosis Pay. I paste that one in there. It validates because you can only add Gnosis card saves here. And I connect this one, and there it is. So this is, yeah, a tracked wallet within Metri, so to speak. So I haven't imported my seed phrase or anything here, but I can still see my balance and some on-chain information here. Not the card number, CVC code, or anything like that. That requires a proper login. So that's functionality that will be added. And here I can see all the transactions done on the safe account. And this is a card purchase I made earlier. And we can identify card payments because they're always done to one specific safe account. So we know when it's a card payment and when it's a other type of transaction done on the safe account. And here I can also show the owners setup. So if I go to wallet owners, this is where I will see yes, here. So for this account, you can see that there are 4 owners. So starting with this externally owned owner. So this is actually the original Circles owner of the account when I created this as part of Circles Garden. Then I have another passkey here that was created, 3rd of May. It was done on Android device. And then I have one passkey here that was created 7th of May. It was done from Safari, iOS, and mobile. And then one that was created yesterday, and the one I'm using now, also created on Safari, iOS. And from here I can manage the owners, so I can remove owners, which requires an on-chain signature. Can also add new owners. So if I have another device I want to add as an owner, I can scan this, create a passkey, and then send a request, which can be picked up and signed from one of the existing owners. Then, yes, going back here. So, yeah, that's pretty much what we wanted to go through with Metri and also the demo. So continue over here to answer hopefully some questions. And yeah, maybe before we try that, we want to mention as well that we're hiring and growing the team. So we're hiring for a senior Web3 software engineer. So if you know anyone, please let us know. And again, here's the QR code if you want to try it out yourself and you haven't done so. Happy to answer any questions anyone might have.
Hello. Yeah, thank you for the presentation. You mentioned that when you create the wallet, you have the ability to import an existing Circles account. Do you have like a different experience if it's an existing Circles account or if it's created from Metri? Or is it the same?
It's very, very similar. Like from a user perspective, if you import your Gnosis Garden account, you will have to provide a 24 seed phrase so that we can do the transaction or sign from the externally owned account. So you need to provide the seed phrase. But after that, it's very similar. You create a passkey on the device, and then we deploy not a new safe account because that's already there, but we deploy the new owner of the safe account. And then from within Metri, afterwards, you can sign transactions from or by using that passkey that was created during the onboarding.
Okay, but in terms of security, etc., it's the same for both options. You wouldn't recommend, like, for example, I just created a Circles Garden account this morning. I don't have any friends at the moment, so I'm wondering if I should create a new one on Metri or just keep using it.
You should import the The one you
Record
have,
it?
yeah.
Okay.
Because it's supposed to be your identity, so
Yeah. Okay.
if you don't want to make Martin mad, yeah.
Okay. Makes sense. Thank you very much.
Thanks for the presentation and the demo, and so very nice. Obviously, I love the Passkey experience. It's amazing. But I have a technical question regarding the Passkey elliptic curve stuff, right? So one of the primary reasons a lot of blockchains like Ethereum blockchain did the 256K1 curve was there was the hesitation of like some kind of NSA backdoor for the standard P256 curve that passkeys and stuff are using. But now to make UX easy, if we switch over to just using that curve, do you think there is a security issue over here?
I kind of want to give it back to the... I actually don't. Yeah, I know about this thing, but I don't know. Like, yeah, I don't know what to answer to that. But yeah, it's like the entire web is based on that. So anyway, yeah. Can we have to accept it? I guess.
Yeah, that's why we moved away from, or we are trying to move away from TradFi. But okay, anyway, thank you.
Thank you for killing the vibe. Joking. No, it's a good valid point. Valid point. Yeah.
I do have one. I have a Circles Garden account. I just imported it like right now, and so the circles are still there. CRC are there. Thank you. And but I saw that you have this mint new CRC button, which I don't have. Is there a admin privilege thing?
I actually twofold answer. So you will see that button when you have kind of a day's worth of circles to mint. So now, for example, if I go back into my wallet, I won't see that button for another 23 hours and 50 minutes because we don't want people to like mint every other minute. But then I do know that Circle's account, the version 1 of Circle accounts, they can go stale or like they can freeze if you're not active. And it could be that your account then is stale and will have to be brought back to life, which isn't possible right now, but it will be with the version 2 of Circles, which is coming out in 2 months or something like that. So your account is probably, you can still use your circles that you have, but the mint functionality isn't there until we migrate to version 2. And the circles team can talk all about that and the new functionality that will be in there. But it could be that your account is stale, and that's why you don't have the mint button.
Yeah, just another easy question. So I also just imported my Circles accounts, and I have a Monerium account also, but obviously that's a different safe. Is there a way to connect it now, or is
so Monerium account is separate. Have some Monerium guys here, so they can also help you out. No, but Monerium account is separate. For Monerium, you have more like a traditional like TradFi account or an IBAN. That's an on-chain IBAN, so you can send money to that one. It will be minted to any address that you want. Right now, there's no connectivity between Metri and Monerium, but we will definitely add that. So very soon you will be able to set your Metri account as your Metri or Monerium wallet. So when you deposit money to your on-chain IBAN, the money will be minted to your Metri account. So it will be just as smooth as like Monerium is today, but with other wallets, but directly into Metri instead and integrated into the UI there. Any other questions? Did we cover it all? I think we covered it all.
Yeah.
But yeah, thanks everyone for listening and coming. And yeah, we are downstairs there, have a booth, and we will be here the whole conference. So just come by and say hi. And yeah, please try it out. We'll be hanging around here, and we have most of the Metri team here as well. So if you have any questions or feedback or anything, yeah, we'll hang around and happy to answer any questions or yeah, feedback. So yeah, thanks very much.
Thank you.
Hi everyone, my name is Tim, and I'm from the Teller team, and I'm here today to talk about the next generation of the Teller Oracle. So first off, I'd like to tell a little story about a few years ago when I was with a friend of mine. We were watching the Kentucky Derby, which is a big horse race in the United States, and neither of us knew much about horse racing at the time, so we decided to make things more interesting. We both bet $20 on the outcome, and so I took the first half of the list of competitors, he took the bottom half, and in the end, I won the bet, but my friend didn't have $20 in his pocket at the time, and I figured he would pay me later, but that day never came. So we're not friends anymore. But anyways, a few years later, I got interested in Ethereum. I thought it was pretty magical how you could create these systems of rule enforcement where everyone has to stick to the rules of the game. No one can defect. And it seemed pretty incredible that you could create these protocols, games that anyone in the world can participate in, no matter if they're anonymous, if they're just random strangers on the internet. You can use distributed state machines, smart contracts, to layer new incentives on top of an existing flawed incentive mechanism from the real world. But there's a giant problem with chains like Ethereum. They're super limited. They only know about their own little deterministic world by default. So if you want to create protocols that depend on external data, you need to solve a problem, you need an oracle. And if you want to build credibly neutral, trustless protocols using things like Ethereum, with oracles, you need your oracle to be credibly neutral and trustless as well. So that leads us to the Teller Oracle, which aims to be trustless and decentralized. And so Teller's been live since 2019. It's gone through multiple iterations since then, but it basically works currently by having a staked set of data reporters, which anyone can stake and become a data reporter, and anyone can pay a dispute fee to dispute any data. And whoever wins the dispute wins the stake plus the dispute fee. So that creates a strong incentive to provide good data. It provides an incentive for people to monitor and validate all the data. And this data is secured optimistically. So that means that it takes a period of time to wait for disputes before data consumers can safely use the data. So as we, the Teller team, have worked in this Oracle space, we've thought about some ways that the Oracle can be improved. One item on this wish list is to have fast, robust data. So there's a certain set of users for whom data latency is a big issue, where their protocol cannot work if the data they have to use has to be 15 minutes old. And then on the other hand, there's a long tail of users that have very custom niche data types that they need. So we think an Oracle should be able to serve those use cases as well. And another point is that it seems we're in the multi-chain world now, so another chain is seemingly deployed every week. So more chains should not be a bottleneck for an Oracle. And finally, the Oracle should be able to achieve all of these objectives and more without compromising on decentralization and trustlessness. So that leads to the next generation of Teller, which is called Teller Layer. It's an L1 Cosmos SDK chain, and it works by aggregating together many reports from multiple reporters. It does this aggregation on chain. It still uses disputes to penalize malicious actors, and then we have this great L1 for aggregating, validating all this data. Then it needs to be useful to users, and we get it to those users by doing light client bridging, which we'll talk a little bit about. So as we've built Layer, there have been some architectural questions, problems that we faced, one of which is who actually should report this data? We have an L1 Cosmos chain, so that follows that we have a staked set of validators already. They already have skin in the game. So that's one potential set of people that could do the data reporting. But a problem with that is that the Tendermint validator set is capped. And remember, we want our Oracle to be able to serve the niche data type, the very custom data type. So if say your validator set is 100 validators, and some user has a very custom data type that they want, they might not be able to convince any of those validators to support their custom data type, maybe their risky data type. So therefore, we chose to split reporting and validating into two separate roles. So the validators are concerned with the deterministic objective chain state, whereas the reporter role is concerned with validating, creating good external data, which includes a lot more subjectivity and not as much determinism. And this reporter set is not capped, it's boundless. So that means that if one of the existing reporters does not support some user's custom data type, that user could choose to go stake and become a reporter themselves, provide their own data, and they gain the security that Teller Layer provides. Another question is, where do the reporter stakes come from? They need to have skin in the game. So one potential place those stakes can come from is by forcing all users to choose between staking to reporters or validators. But we didn't like that solution. That would cause some competition between those two sets of roles. And that would mean that if someone chooses to stake to validators, the reporter set is less secure. An alternative solution would be to create another separate second token. But again, that seems to probably create some of the similar competition between the two roles. So we opted to use a dual delegation model. So validator stakes can be redelegated to the reporter set, which creates some capital efficiency in the system. And this type of restaking probably doesn't have some of the same drawbacks as other restaking. They're redelegating within a unified system. Reporters and validators on this chain have very intertwined interests. Now, on a separate topic, we have light client bridging. One of the reasons we chose Tendermint for our new Teller upgrade is that Tendermint is very light client friendly. So Tendermint consensus prioritizes finality over liveness. And that makes it easy for light clients to efficiently reason about, determine what the chain state is. And users can still use that light client method, like the base light client method of verifying 2/3 of validators sign the block header, and then using Merkle proofs to find your data within the chain state. But we took it a step further by creating these Oracle attestations. So with each data report, all validators sign just the data and some metadata. And so then users don't necessarily have to deal with the Merkle proofs, finding the specific Oracle data within the full chain state. So we think that's cleaner for users that are trying to bridge data. But again, we don't really care, Layer doesn't really care how users read the data. So users can choose one of these two options. They can create their own method. And getting in the weeds a little bit for those that might be interested, using Cosmos, we have a fairly new upgrade from Cosmos, or an ability called vote extensions. So that allows you to add extra work and logic for the validator set. And you can do that without directly editing the consensus mechanism itself. You add this on the application layer. Now, another problem with the light client bridge is that a light client has to be able to track, has to be aware of the validator set. So each time you update the validator set in the bridge contract, you're costing gas. And so we wanted to limit those gas costs in the bridge contract, so we created a threshold that under which you don't have to update the validator set in the light client. On a separate note, we created a 5% limit on how much the validator set can change within a 12-hour period, so that slows down the amount of validator set updating you have to do in the light client bridge. And also it has the added benefit that it slows down changes on our chain itself in the validator on some particular attacks. Another point is that us having an L1 gives us the ability to have social consensus as a final backstop of security for our whole protocol. So if the unfortunate situation arises where some malicious actor takes over 2/3 plus percent of our chain, we could always choose to fork our chain. All the good community members, good actors, can choose to go in the good direction and slash the bad actors. So that creates the ability to secure more value than even our whole market cap. But there's still kind of an open question in that complete solution where we can do that perfect social consensus recovery, forking on our own chain. But then once you go over to the user chains where the light client bridge exists, that doesn't know about which correct fork to go with. So there's some interesting ideas, research out there about how to solve those problems, but I think that's outside of the scope of this talk. Another question we faced with creating teller layer was, how does data finality work? So remember, we want to create fast data. Some users depend on being able to consume some data immediately, which doesn't work for optimistic data. And so the way that we've added the ability to create fast data, to secure data quickly with teller layer, is that we do on-chain aggregation of many reports. So we take a median or mode depending on the use case. And that also means that there's potentially the whole chain stake backing a particular piece of data. So we consider that if 2/3 of the reporter set has contributed to a piece of data, that data is considered robust data, which can be consumed immediately without any dispute waiting period. So I should point out that all data reporting is optional. There is no activity leak, there's no penalty for failure to report data at any given time. And the reason for that is that we, as an Oracle, we're interfacing with the outside world where things are not deterministic, they're very subjective. APIs can go down, or we find edge cases and definitions that weren't accounted for. So you might argue that maybe in times of high uncertainty, no one should report any data, and Oracle consumers should handle those cases themselves. Continuing with the data finality, on the opposite side of fast data, we still have our optimistic data, which will likely cover more custom niche data types These might be just very unpopular or less popular types of data that most people don't have access to finding the sources for, or they just don't have any interest in supporting this data type. It might be more risky data. But so we consider that if less than 2/3 of the reporter set contributes to an aggregate report, that's considered optimistic data. So in that case, users still build in a dispute waiting period to achieve probabilistic finality over a period of time. If no one disputes a piece of data, that's a strong indicator that the data is good. So, yeah, I think I'm going faster live than I did on my own, but just to recap, Teller Layer has created some extra capabilities for the Teller Oracle. So first of all, we've achieved fast, robust data. We also still support very flexible data types. People can define their own data type, whatever they want, and they can become the reporter themselves for that data type if they want. With Teller Layer, more chains is not a bottleneck. So with current Teller, we're a set of contracts, and on each new chain that wants to use us, people have to stake on that new chain. And that splits our security thin as we split our stakes among each of those chains. And then there's also dependency on token bridges and the risks that come with each different implementation of those. So with Teller Layer, we've concentrated our security on this one L1, where all data is secured, created, validated. And we've done all this while still remaining trustless, incredibly neutral. And so I'd like to say that everyone in this room is in a unique position to build amazing new protocols with this great new medium tool of crypto economics, state machines. And if you are building a protocol that depends on external data, I'd welcome you to check out the Teller Oracle as a solution. And you can join the Teller Discord to join in on the discussion. Are there any questions?
So you mentioned in the case of a 2/3 attack, you can regain consensus on the Teller layer by social consensus. Right. But downstream of that, the consumers of all the Teller oracles will have already kind of been in trouble, no? So like the time to reach social consensus, like how do you imagine that process, like in like an example?
Yeah, that kind of creates a bit of you might need another waiting period then if you really want to guard against that. Or one of the proposals, like I mentioned, that there's people looking into this problem. One proposal is to implement social recovery at all layers. So, yeah, which is a big ask, but that's the only solution that I've thought of so far. And I didn't think of it myself, but yeah. Yeah.
Hello. Before it gets to that, some of the backstops that we have in place, it's basically the fact that we don't allow more than 5% of the staked amount to be transferred into the chain, and then also more than 5% of the weight of the validators to be changed within 12 hours. So if somebody was trying to switch or take over the chain, that would be one way that we would sort of know in advance. Not sure that we could stop it completely, but that would be one way that we could start thinking about that. And it would just take a long time, and also to take over 2/3 of the staked TRB or the staked amounts, it's pretty expensive because then you're going to lose it.
Any more questions? No. Good. Thank you.
Mm. Okay. Yeah, sure. Hi, everybody. What's going on? Beautiful day. Glad to be here. My name is Garrett. I run a fund called Permanent Ventures, and we focus mostly on like decentralized applications, which are set up to exist forever. and have just be very long lasting with the right token economics and incentives, such that ideally the projects will survive the founding team. I just think that's one of the most interesting aspects of crypto, is like the ability to create things which survive beyond the creators, which isn't as often the case in traditional companies. So today we'll be talking about the decentralized storage landscape, specifically about VMs that are emerging. So start off just giving a little bit of a overview of all of the competitors throughout the past that have started decentralized storage projects. Some of them have pivoted into decentralized compute, and others have become a little bit too centralized to be considered anymore. It's a space that I've personally been following since like Storj and Swarm and some of the earliest attempts. Today we're left with the kind of most popular four: Arweave, Filecoin, ETH, Swarm, and of those, the two that are most used and that are actively developing their own virtual machines are just Arweave and Filecoin. So those are the two that we'll compare mostly. And so the respective virtual machines that they're working on. Arweave launched a testnet of AO a couple months back, which is a actor-oriented message passing network. And Filecoin also launched a actor-oriented message passing network like a year ago in March. And it's really interesting to see I think in particular, like the convergence of the two networks in terms of their storage offerings in particular, because of what a more generalized virtual machine enables. So we'll talk a little bit about that too. There's a bit of background to this talk, which you might be interested in if you're interested in these two networks in particular. This was like a similar kind of talk, just diving into the protocol differences, because now we'll just talk about the virtual machines. And there's actually a lot more that's different on the protocol side. Can recommend that as like a attempt at a relatively unbiased comparison between the two. And there'll also be a link to these slides at the end. So. Just a little bit of an overview on what was discussed in that talk was these are like, if you really boil it down, like the key differences. So there's everything from obvious like language implementations to the validation proofs, and but the main differences that are important to note is that Filecoin is its intentions are to be like a decentralized broker of storage. So then you have sellers and buyers of storage facilities, and you enter into time-based agreements on how long you want this storage for. And it does great at that. Arweave is a protocol which has an endowment built in, which guarantees that if you upload something to the network, it will pay out rewards to miners indefinitely, like in perpetuity, ideally, making some game theoretic assumptions and so on, that the storage will always be there. So there's a couple nuances there, but you can look at that to dive into those. The main topics of interest for today's talk, virtual machines and the applications we can build on those. Main thing important to note is that I think the convergence of storage offerings is pretty interesting. Like, so Arweave as a permanent only data storage layer through the use of a virtual machine can offer term-based storage for the first time. And Filecoin, on the flip side, through the use of a virtual machine can offer perpetual storage. So the offerings converge, and that's pretty interesting. And because of each of those initial protocol level trade-offs, how virtual machines are implemented is obviously going to be different. I think probably the most interesting use case for these networks is going to be like autonomous agents and AI inference in a truly decentralized way, because of the nature of each of them to run like arbitrary levels of compute. So there's a big difference here in the two kind of virtual machines that are initially supported on each of the networks. Filecoin virtual machine is focusing on making a version of the EVM that runs natively, so then you can easily port over DeFi primitives and so on. And so far, it's mostly used for like Filecoin restaking and lending to miners, so then they have more liquidity and access to being able to scale up their mining operations without needing to put up as much capital up front, which is great. WebAssembly though is like natively and inherently like just much more flexible in what you can do. Especially after we get over this initial limitation with WebAssembly 1 only allowing up to 4 GB of memory. So for instance, if you wanted to run some kind of language model inside of WebAssembly under AO or under FVM, once they support that, then you can, not right now you're limited to like a LLM, which is slightly less than 4 GB, right? So it's not as interesting. So for example, like if you guys use ChatGPT or something like that, you'll want to be using a model that uses much more RAM than that, maybe up to like 30, 40, 50 gigs. So once we can run those kind of more serious models inside of this decentralized compute paradigm of these protocols, leveraging the data stored on each of them, it's really fascinating what we can do. Something that Arweave are working on implementing with AO is like that 64-bit memory space, which will be really cool. Both of them, AO and FVM, are VM agnostic. FVM are starting by implementing EVM. And AO are starting by making WASM the default. But the idea with both of them is to make it so you can plug in your own VM, whatever you want to use. And that'll make it very flexible in terms of what can be run on the networks. Both networks use an actor model, so basing on message passing, which is great for like massively parallelized compute in a decentralized way. So I thought I'd put up like what is the actor model here, but basically it means that each node on the network or agent that's executing code is communicating with others just by message passing and acting based on when they receive a message and send it back. So that way you can run like a massively parallel computing paradigm instead of having like a monolithic state like we're used to with most blockchains today. So where they start to get a bit different is kind of like the intentions of what's being built out first. So in FVM you have the FEVM, whereas in AO you have this interesting like SSI model where you have a kind of initial image that you boot up from, and then there's different roles within that can be assigned to the node that you spin up. So you can schedule tasks, you can do compute. For instance, some compute units will be good at CPU, some will have GPUs attached, and others that are meant for sending messages. And then with AO, of course, you can think of it as L2 that settles on Arweave, which of course inherits its security. So I think I just said that, but EVM first versus message passing first, but eventually, the convergence between these two networks will probably be even stronger and more prevalent when, AO will also implement like an EVM, and FVM will also implement like ways of doing message passing. So right now they're quite different, but ideally, if they both materialize in like the visions that they have, then it should look pretty similar in the end, which is kind of cool. I think it's very validating for each of the projects that they want to go in such similar like end directions. But both of them will be able to manage storage deals through virtual machines, which is really powerful for implementing the perpetual storage on Filecoin and temporary storage on AO. Doing compute on data that's natively stored on each of these blockchains and storage platforms is really interesting. So having native access to large amounts of data and being able to do compute on those without needing to worry about transporting that over the internet over long distance, and having the nodes that do that compute, maybe even in the same computer or the same data center, can be really, really good for optimizing for cost in like a decentralized compute paradigm. So probably like the most interesting thing that's going to occur here is in AI inference. FVM will be well equipped for this because they've subsidized mining to such a huge extent that there's been a massive infrastructure build out that has very high levels of like compute on GPU and CPU and RAM. In data centers all over. So, the miners on that network, even though currently, it's, a lot of the miners are kind of winding down or going dormant because the subsidies for mining are decreasing. There could be a lot that's just waiting for the use cases in like AI inference, for example, to come back online, and then the infrastructure will be there, which is pretty cool. AO is taking more of like an organic open model where people will join the network without massive upfront subsidies, and hopefully like it'll be driven by just demand in the marketplace as it has been so far. Historically, inflation and like levels of subsidies from miners on Filecoin has been pretty high. It's lowering a lot. But consistently throughout for Arweave, it's been low. So there's been like less network build out, but it's always just kind of kept up with the demand for storage. And then the storage offering convergence. We discussed this already. I think it's going to be pretty fascinating because of the implications that each have. But so key summaries are you got the actor model, native storage access. And the main thing is the convergence. And for differences, FVM is focusing on being a hypervisor and a normal kind of EVM blockchain first, implementing WASM support later. AO's more general system image that you can load up and boot whatever kind of process you want inside of, and then pass messages around to other nodes. So right now, that's what that's looking like. And then the kind of how that's evolved over the past like month or so is mainly like I would have been a lot more kind of unbiased like a month ago, I would say. Saying that like let's see what happens with these two. But in the past month, the amount of like developer attention on AO has been like massive. I think because the kind of AO team are building, way more quickly and way more perhaps scrappily, just kind of like putting stuff out there, iterating fast, not being too worried about the implications because it's just a test net. There's less to worry about naturally. So that's allowed developers to experiment a lot faster and attracted people that are building like autonomous AI like agentic systems on top of it. Starting new DeFi primitives and building like stable coins and dexes and all the kind of stuff that you would need from scratch as well, instead of like porting it over from EVM. So it's interesting to just see like all the opportunities that emerge through like a more WASM native virtual machine. And then because FVM is in mainnet already, and I think in general the team there are much more cautious about rolling out new features and so on. It just evolves more slowly. Obviously it's super important to make things secure. So it's probably smart of them to do that as well. But yeah, it's just really exciting times right now, kind of in the AO ecosystem. So I could encourage developers who are interested in like building a new compute paradigms to build that out. But yeah, that's all I've got for you guys. So thank you, and let me know if you got any questions.
Hey, hello.
Hey.
Thanks for the presentation. That was good. I wanted to ask, so if there's all these DeFi primitives starting to happen on AO, say, you see in the future that like the liquidity also like as it is now between L2s, is it also going to happen? You think it's going to happen also with AO? There's like even liquidity going into that, which splits with all these other chains.
Yeah, for sure there will be bridges, and like you'll see integrations with really popular bridges onto any network where there's opportunity for sure. So yeah, there will be like liquidity moving between like AO and other L2s and so on for sure. But having a natively implemented, like stablecoin, for example, is also nice. So until like Tether and Circle like USDC come and say like, okay, we're going to deploy our own smart contracts natively and natively support AO, for example, or whatever other network it might be. It's really important to have like a native stablecoin that's not dependent on some third-party bridge that not everybody would necessarily want to trust. So, yeah.
So are people rebuilding the DeFi primitives in WASM now on the AO chain?
Yeah. It's definitely a lot of work, but it's and people are also building like a EVM compatible chain that sits on AO as well, and doing that. So yeah, both are happening. Yeah.
Okay. What are you more, bullish on? Like, what do you think makes more sense? Because like reinventing all the DeFi primitives in WASM doesn't sound like very, like, do you want to repeat all the bugs that like the EVM had at the beginning? Or like stuff like that.
Yeah, that'll be a lot of extra work for sure. But in the short term, for sure, just like copy pasting, things that are already audited, definitely makes more sense. But in the long term, I think having stuff like natively in WASM on AO will be very interesting. Like there'll be just more like things you can do. It's like less limited as a environment. So yeah, both are necessary. Well, I guess you're doubting the necessary word, but but I think it's fun to see.
One question since
Yeah.
I came super late, so I missed. Can you give us a 10-second TLDR of AO versus 10 seconds?
Can you put the slide back up? Okay. 10-second difference is okay. We got mainnet on file like FVM that's been around for a while. They're focused mostly on building an EVM inside of it first. Which is what you can use and enjoy today, like staking fill and lending it to miners and so on. And AO are focused on WASM first. So I think that's the most important TLDR difference. Yeah. Cool. All right. Thanks everybody.
So good? Cool. So, intents are not real without the intent engine. I'm Connor Howe, one of the co-founders of Enso. I've been building on Ethereum full-time for the last 8 years. Prior to that, I was in Bitcoin in 2013. And Enso's went through many evolutions to be able to get to where it is as of today. The agenda of today will be giving you a bit of context of the evolution of Enso, so you can get some insight into how we ended up to intents, what are intents, and the Enso network. The Enso network is not being publicized anywhere. There's no blogs, there's no tweets, so you're getting real alpha today. So crypto projects generally have two choices. Either artificially create product market fit by launching a token. Hopefully you survive after 2-3 years. Most don't. Or you go through the fog of unknown. That's what we done with Enso. We started off with a vampire attack. We attacked 6 different protocols, gamified this whole experience, and incentivized it with NFTs. We then launched social trading, where anybody could create a social strategy of monetizing your investments into DeFi and ERC20 tokens. Whilst building this, we found a massive problem, was how do we integrate all of DeFi simply, conveniently, without spending over $500,000 in audits, which we did, only for 15 DeFi protocols. So went back to the drawing board, rebuilt everything from scratch, and had one holistic UI for interacting with all of DeFi. Whilst building this, the architecture underneath, we built in a very nice way that we're able to integrate a new DeFi protocol from inception to production within 30 minutes safely. But users, again, don't use a product unless you give them free money, which doesn't really make sense. But we got a light bulb moment, which was everyone else has, not everyone, but many people have the same problem as us in the V1 of how to integrate all of DeFi into your product. We spoke to many projects and teams, and 2 results came out from this. The question was, how do we get users? 1, launch a token. 2, we have the same issue, so we spun up an API, and within the first week of the API, we got 11 million volume, more accumulated over the 2 years of Enso being around. So that's what you know Enso as of today. This DeFi middle layer enabling application developers to embed DeFi actions into their products, ranging from lending, borrowing, swapping, LPs, and vaults. So if you're a developer and you're building a wallet, a treasury management tool, whatever it may be, and you want to offer your users DeFi, you don't need to build it all over again, manually one by one. You can simply just call our API for this. And in a matter of 3 years, we went from first year of $8 million to 200K to now 12 billion plus, with 35 plus projects using us in production, all without incentivizing this with a token. Whilst we were building this, we always had user centricity at the forefront. Users want to interact with DeFi without needing to know every single individual complexity of how to interact with that DeFi protocol. So let's say, for example, you want to interact with Beefy that requires an Aura LP, that requires a Balancer LP, that requires 3 individual tokens. With Enso, you can just say, I want that Balancer LP, and we'll abstract all that away for you, or Beefy LP. We call this shortcuts of blockchain. Other people call this intents. For those who don't know what intents are, they're really not that complex. Some people like to make them sound more complex than what they are. But it's saying, I have A, and I want B, C, and D. And I don't care how you get that for me. All of this logic of how to get that is abstracted away for the developer. And B, C, and D could be a token, state, NFT, DeFi position, or any interaction on-chain. You may have heard a lot of hype about intents, and if a user wants to express their intention to go from token A to a DeFi position, you'll go to what people call an intent network. there's many different intent networks, as you can see. All these intent networks inherently are is a job bulletin board. So you go to LinkedIn Jobs, you go to Fiverr, you go to Glassdoor, Upwork. You say, I have A, which is money, in the context of a job, and I want this task to be done. It's the exact same for an intent network. And underneath, people that fulfill this task or this intent are called solvers. Some people call them resolvers, some people call them fillers, some people call them transmitters. Whatever name somebody creates next is the same thing. I have a task, I have A, and I want B, C, and D, and somebody figures out how to do that for you. But all solvers really are doing, as of today, is swapping from token A to token B. There's only 2 players in this whole ecosystem that are doing non-just token swaps. So for example, if you want to be a solver, you're creating this map of all smart contract interactions. Token A goes into this contract, token B comes out, and you start to graph all of these relationships. To give you a visual representation, this is one of the orders we fulfilled. This is doing 112 different individual transactions to be able to obtain the most optimal route for the user. So you start to see that these are individual points in a map and how all these relationships start to connect with each other. Yeah, I mean, you can see the extent of this, right? It's quite big. I'm not going to explain every one. But again, the ecosystem is not just about tokens. B, C, and D could be a token, a DeFi position, an NFT, a state outcome. It could be an approval. It could be a transfer. It could be a mint. It could be any smart contract interaction on chain. Our vision of this ecosystem is all developer interactions will be intent-based in the future. Defining what you want and not how you should get that makes the most logical sense. As a developer that wants to offer maybe a DeFi product, a DeFi protocol in their product, they need to integrate maybe 4 or 5 different DeFi protocols before they can even offer that to their users. So these developers are turning into a dev shop, an integration house for building every single integration, waiting for audit slots, looking at 4 or 5, 6 months before you can release an MVP of maybe just one DeFi protocol your user asked for. This is where Enso comes in. So we have built the world's first fully decentralized shared network state for building transactable data across all blockchain frameworks. It's its own blockchain. And this word choice of a shared network state, to really just break this down, the world is a map, right? You have many different countries in a world. You have many different cities in a country. And the Enso state is a world of all smart contract interactions across all blockchain frameworks. So in this case, Ethereum can be represented as a country. Each individual smart contract you can see as a city. By having all of this within one place, we can then start understanding the relationships, how they intertwine, how they communicate with each other, not only for tokens, but for any smart contract interaction on chain. Similar to how a train line may work. You want to go from point A to point B. You're going through many different cities to be able to get there. With this, as a full map, we can start understanding the relationships of smart contract interactions. And all of this turns all developer experience into purely outcome-based. If you have all smart contracts, how they intertwine, how to build executable data, of being able to only specify your outcome, developers don't need to care about all the individual nuances for every single smart contract they integrate. Developers can now just say, I want this, instead of each individual step they have to build manually. So a developer would come to the ENSO network, specify their intent. The intent could be, again, an NFT, DeFi position, a token, a state override, and all of the individual parts to be able to obtain that is abstracted away with the ENSO network. For example, even approvals that's required as a prerequisite is abstracted. The three different network participants we have is an action provider, a grapher, and a validator. We have competition, but also collaborativeness between network participants. An action provider you can envision is somebody coming along and saying, here's how you interact with a smart contract, conforming to a standard that ENSO has built. Similarly, how a developer goes to subgraph, well, the graph, and creates a subgraph that other people consume. Let's say, for example, you want Avi lending. You will come along to the ENSO network. Here's how to lend on Avi. This now is a plot inside of the ENSO map. The graphers will listen to intent requests. These are purely mathematicians that do not care about where the data is coming from. Mathematicians don't care that it's blockchain data. They just traverse every single action on the ENSO map for building the most optimal solution. These graphers will propose their solution of bytecode of how to solve the intent into the mempool on the Cosmos chain. Validators will then simulate this and then find the most optimal solution that was proposed. These validators in the background are running transaction simulation tools. We open sourced our transaction simulation tool about 10 months ago. It's called Temper. So if you are using Tenderly, you can just use this for free. So ENSO is this full map of all smart contract interactions. You need people to contribute actions to the network. So a developer, maybe in this room, comes along and says, I want to add this abstraction for the smart contract. If you add this, you get a fee of all solutions that are being built using that action. The question you may have is, what does this turn into domain squatting? Not necessarily, because there's a full economy of token staking on top of the actions that get provided. So if an intent solution comes in and two actions are the same, the one that has the most amount of ENSO token that's staked gets selected for that solution. Why? Intents aren't real without the intent engine. Intents are purely just job bulletin boards. You need people underneath to fulfill these different intents. We cannot build hundreds of thousands of job bulletin boards when there's only really a handful of solvers in the ecosystem that are only doing token swaps as of today. As this ecosystem grows, which it is, with the amount of blockchains, the amount of layer 2s, roll-up as a service, we're turning into this real multi-chain future, and we keep forgetting developers want to integrate all of this. If you integrate one blockchain, you have to build months for this, have all infrastructure for this, and then integrate each smart contract. This does not scale, integrating every single chain manually itself. And we need people to use this technology. If we expect developers to integrate everything manually, it doesn't work. We learned that ourselves the hard way in the version 1 of ENSO. Spent over a year integrating 15 DeFi protocols, over $500,000 in audits. If we want people to build products on top of this, they need a convenient way of embedding all blockchain into their applications. So what we're going to build whatever, however, wherever, using ENSO. Abstracts all of this away for you to embed all blockchain into your product. The only limitation really is your imagination. Now you don't need to spend months integrating every protocol. Yeah, that's the presentation. If you want to contact me, Connor and ENSO, and the email. Still got 5 minutes, you know? We are hiring. So 2 Rust engineers, a Twitter intern. If you like to shitpost, let me know. Developer relations, Cosmos developers, and if you think you are, well, maybe you shouldn't be hiring, you know? Yeah, exactly. Is it the head? Oh, there you go. But if you think you will be a fit, and we have, if I turn my head, no, just reach out to me. And yeah, thank you. If anyone's got any questions.
Hey, thanks for the talk. Staying in your map analogy, how do you add new cities to your map? Is it a Google Maps or an OpenStreetMap, like new smart contracts? Like staying in your map analogy, how do you add new smart contracts to your protocol?
It's a standardization of different primitives. You come along and plug it in, and you say, here's how you land on Aave. Here's how to execute. So anyone can do it. It's not really deploying a new smart contract. It's just like an interface layer of knowing how to interact with these other smart contracts.
I assume the proofs depend on a certain state of the blockchain. So how do you make sure that the blockchain does not change in a way that the proofs are not valid when the actual execution happens?
So there's no real proofs inside of this. It's more once you call action to not only, I didn't say it in the presentation, but you specify how to execute and also how to validate that execution happens. Then the validators are then going through each individual action which is used, comprised of the solution, and then also validating inside for these individual getters. And they're also so maybe the getter's not there. Validators can start adding custom modules for then state override.
I run a bit of infrastructure. I can code. How can I participate in Enso?
So there's 3 different parts. If you can code, 1, you can build smart contract abstractions and just contribute them to the network. I recommend you to start doing it whenever it's live from day 1, because all the solutions that are being generated, you will get portions of that fees. So it's kind of like you're front-running other people contributing to the network. This I wouldn't recommend graphers if you're a coder, because it's purely mathematicians. And then the third one is a validator. So if you've run any nodes before, just take this Docker image and then just run it.
What about the graph?
Yeah, I wouldn't really say it's more, I wouldn't think that's a coder. It's a purely mathematician. So you're doing like k-shortest paths, you're building custom algos to traverse a whole map. You can do that if you want, but I think validators and action providers probably easier for you. Oh, I've got 2 now, okay. Double whammy.
Thanks for the presentation. Maybe just one quick thing. So if I wanted to, say I have a Dapp and I wanted to offer my users to deposit something, some funds on Aave and do something with yield, I'd have to build an intent, and then I could use that intent, and anyone else could use that same intent.
It's a really good question. Right now, no. So you're basically saying specify and then storing this somewhere so people can reuse what you've requested, right? No. But what you can do as a DAO, you can just call the Enso API and it's fully abstracted away. So you would store, most likely in your backend, hey, I want to go from A to B, and this could be landing on Aave. So you know that call would generate the call data, and then the user would execute themselves. If you do want to make it more funky, you can use Gelato Web3 functions. So you can kind of automate this whole process under these conditions. If APY on Aave is X, call Enso API, get call data, and then also Gelato can execute on behalf of the smart wallet or the smart account.
Thanks.
Thank you. I'm just wondering, what is your business model? How are you charging?
Right now, it's kind of take and spread comparison to other people. So the assumption is not only are we going to have direct developers using us, we're also going to have other intent networks consuming us. So for example, like we're solving CowSwap, Brink users, Aperture, many different intent networks. We can see what our solutions are compared to other people as well inside of this, and then we can take the percentage difference. Moving forward, most likely a fixed fee, variable based upon how much volume is coming through this, whoever's consuming the network. Right now, TBD.
Okay, and then one follow-on question then. You said you can see how good your solutions are compared to other solutions, and that solution you showed was really looking highly complex. I'm just wondering, what kind of improvement are you currently seeing your solutions offer over the best in the market compared to you?
So we're not the best at token swaps, like probably not public knowledge, but now it is. We're more good at DeFi routing. So like one with another person are the only ones doing DeFi routing. So our edge is being able to interact with a new DeFi protocol very quickly. Let's say you want to get into SDAI. Many people try and purchase that on a secondary exchange, but the most optimal route may be swap into X different tokens and then mint SDAI directly. So that's kind of one of our edges.
Okay, cool. Thank you.
Yeah, hi. So what part of the solution are centralized, what are off-chain, on-chain? Because if we are talking about competitive routing solutions, for example, like Uniswap X or CowSwap or solvers, so they have different type of centralization inside the system.
Are you asking about them or the answer?
No, I'm asking about you. So as I understand, these interfaces, they are not on the blockchain, they are on the backend or on the API levels. So what parts are on the backend, what parts are on the off-chain, you know?
So as of today, it's fully centralized. Once the network goes live, it will be the validators first, and then over time will be individual graphers. The graphers will be running their own proprietary algos off-chain. They won't be putting that on-chain. They'll be putting the solutions generated from their algos on-chain. Then the action providers, that's put on-chain. So people saying, here's how to interact with a protocol. Over time, it'll be individual RPC requests that are being made to the network itself.
Mm-hmm. Okay, thank you.
How far do you abstract away the intent? So, for example, if I want to take on, let's say I have $1,000 in Ethereum and I want to take on 1.1 leverage on that Ethereum, and like I do that through lending markets, do I need to specify in my intent that I want to do this on Aave or Maker, or can you kind of abstract that away completely?
Yeah, so I think people will build tools like that on top, and it will turn into 3 different types of intents. Explicit, i.e., I want to do my leverage on that protocol. That's like explicit. Semi-explicit is I want to obtain this leverage. But you're creating these boundaries that solvers can then still use. So maybe it could be an Aave, maybe it could be a Maker, maybe it could be GMX, whatever it may be. And then the third one is not really explicit at all. And it would be a AI execution bot that's learned from your previous behavior or what you would do in these market conditions.
I want more money is the intent.
Really though? Really? Thank you.
Hi everyone, my name is Tigan. Some of you know me as the Kinetics man. Today I would like to talk about the internet, new era of internet, DeFi, intents, where we are now and what we are building in DeFi and how the DeFi affected on a whole system of entire system of internet and what we are in Kinetics do here. So I will start from the beginning because organizers they give me 20 minutes. I need to spend it right. Let's take a look on an early stage of the internet, how it was difficult to create a website. I even don't say about to build or develop some software. It was possible only for big companies. And let's take a look of the evolution of internet. So everything starts from ARPANET and TCP, IP, Ethernet. We start to building manufacturing for computers, for mobile. Sorry for that. For mobile, one of the biggest push which was happened in our century is email and DNS. It's when we start to to translate, move data instantly, and World Wide Web. So I know a lot of people say that crypto is a speculation, but if you take a look on the history, the boom of .com, it was also speculation. That's how we can attract attention of key partners like developers, venture capitalists, users for mass adoption. After this, during the 40 years, the internet was extremely developed. So we got a lot of things which was not comfortable. And it's not possible to understand right now our life without this. It's like a search engine mechanism, mobile, internet data, Web 2, infrastructure, clouds, everything like this. And if you take a look where we are right now, around us is AI, robotics, IoT, quantum computing, but it's still not enough. As we can see, during this evolution, most of the companies, like OG companies, they get control of the data and technologies. But if we talk about the technologies like AI, social system, banking system, robotics, could be really dangerous that a few companies just control it in their hands. So that's why we need to have a decentralized technology and distributed networks. For example, how the internet looks right now for us. For example, if I wanted to do any searches in the internet, I need to open hundreds of websites. I need to analyze all the info by myself to get where is the fake, where is the sponsored, which one is true. And I always need to play with the wording. So the same as with AI. I need to put exactly the name of my request and get the result. I'm not sure that this is a perfect system or ideal system. And if we would like to talk about how the system probably will look in the future and what's the ideal model of this, so we in Kinetics believe that it will be a modular and intent-based system. Where the top level, it's applications. Applications can be anyone, so we can go out of the Web3, and also we can use it can be synchronized with the traditional economics, so we can use a taxi service, real estate, some e-commerce, infrastructure, whatever. The next level, it's a delegation, and we call it intents. So it's the meaning of this is when I can ask somebody, like a professional market maker or professional player, to help solve me my task with the guarantee. After this, going level of AI agents, because AI agents, they cannot work right now independently. So we need to monitor, focus them, and we need to learn them. The layer of infrastructure where the AIs can be run is blockchains. So it's some kind of layer where we can execute everything. And under the hood, it's like governance layer with a consensus of verification. Let's take it deeply. So what is this? Why we need the intents in this? For example, I have a request, and I don't want to really go deeply and understand how all the complex things working, for example, for me, if I want to receive like a passive income. I want to send this, I want to send my intent to the auction where the like professional players, they can start a competition in an auction and provide me with a quote, like quote of the bid. As soon as we match the order, before the user sign it, we need to be sure that my intent is secured, and solvers there provide the collateral. The next level, the solvers, they can use the help of AI agent. So they can help them to like analyze a lot of data, use a search mechanism to develop the code, execute the code, and make it more efficient. After this, we can go to the level of execution. In my opinion, right now, the blockchain is some kind of part of speculations because we're not enough get from this technology. And as soon as we get enough, it probably will be on a state of, in a level of state. So for example, like when the governments, they can start to creating their own digital currency like euro, dollars, yen, or whatever. And inside these blockchains, the company, they will do their own solutions, which can be built on all the like type of business what we have right now. Is like similar like World Wide Web, but with more functionality. And the level of ZK is we need it because all the data in the blockchain it's public and transparent. So we need to provide the privacy for this and make it more confidential. But this ZK stuff is not only for the confidentials. Is, for example, like if you take a look what's happened right now with the Saxent Labs platform, they create amazing solution like SP1 when I can, for example, use my basic calculator. I do a lot of calculation stuff during the whole day. Next day, my partner can ask me like, what is the result? I say, I get result XYZ. And he said, okay, I want to check it. So, but I can provide for him algorithm how we can prove, how I can prove all my calculations, and we don't need to do it again. So that's the future. And if we take a look right now how the DeFi looks for the like general users, it's a lot of information that they need to keep in mind. It's like oracles, gas, bridging, swaps, RPC, nodes, whatever. So basically, you need to have a good knowledge of Kung Fu in a DeFi to not like lose your money just in one click. And what we are doing here in the Kinetics. So we are creating modular framework for chain abstraction applications where users can delegate their tasks. So if you take on the common DeFi problems, we can manage them in different groups. For example, users, they need to use the experimental UI and take all the responsibility. So they need to have a good knowledge of Kung Fu in a DeFi to set all the settings like a slippage tolerance, price impact. The developers, they need to create an infrastructure for this. So they need to take the responsible for all the mechanisms like oracles, price rate, nodes. They need to use a bridge system with entrust to like wrap tokens. And the same problem with the networks. Networks, they always need to attract like experienced users and like put all the responsibility to the users about all the sections. I think this is not a really good solution. So for example, let's imagine how I will move my assets, for example, like in some rate staking protocol if I have like Solana or Bitcoin, let's say. So I need to switch wallets, find the bridge. I need to bridge my asset to another network. I also need to keep a gas, pay for the gas, set all the settings. After I go into do a stake, I receive my virtual token, Sometimes I need to wrap it. I put it in a restaking, and finally I get my LRT token. And for example, if I use like a buffer system and I want to double my points, I need to also create a pair in a like pool of Curvy, and I need to know exactly how much to put, like what proportion, or my tokens can be just moved in one token to another. And the solution, what we would like to offer, it's like a new generation of application which we can build. It's a chain abstraction. So chain abstraction, we call it because we don't need to care, like the users, they don't need to care anymore about how to like bridge and how to communicate with all the different networks. One click, because we can create any combination of intents. Gasless is because the resolvers, they also can take care about the gas. So basically, I want to express my intent. For example, I say I want to pay in A and receive a B. And resolvers can you do like under the hood everything just in one combined transaction across the network. And the current system is also broken for the developers. For example, when the developers would like to launch some store in a Web 2, I can use a lot of solution out of the box. For example, I can use a WordPress engine to develop my website just in a few weeks. After I will integrate the payment system, delivery system, and that's all. I can start to receive advertising and sell my goods. But in a DeFi, it's not look like this. In DeFi, we need to care about all the different things. It's like how to connect different wallets, how to create the contracts with the audits, how to do a bridging at multi-chain infrastructure. So this is the biggest problem for the developers. If I open the pool in one network and I want to attract liquidity, I locked inside this network. So for example, it's like a new L2 network on the Bitcoin, and they have not much users right now. It will be really a big problem for me, and I need to explain to all the users how to do the bridging system, like previously I said it. And what we are doing, we are creating interface for the developers and for the users, where you can delegate and create an intent-based model which can be integrated in your any application easily, just using API. So you can concentrate more on your business side, and you can concentrate of the logic, like what you are developing. So you can attract, for example, like it's a new L2 network on a Bitcoin, and you need to attract the new users. So you can easily integrate it in your application just in one click. The users, they can put LRT token, LST token, or whatever, and they don't need to like care, because everything what will do resolver, they will do with like fixed rate and without like all these kung fu things like a slippage. So the layer of this is on top is the user. When the user communicate with the applications, like a wallet or any protocols, and a settlement layer, it's resolvers. When the resolvers like under the hood on the back end create roles for this and algorithms how to do it. Execution level is networks where we can launch it, and validation level on the back end where we can prove all of this information. So how the ZK-like clients work in our solution? So like in a simple word, we take all the historical data from the Bitcoin, and we deploy it. We shrink it to a small like client and deploy it on a Gnosis network. So right now, using just a smart contract open source, we can easily read all the state from the Bitcoin, and for us, it's super cheap update in the batch mode. For example, like we can take 250-60 blocks and upload there like 10,000 of transactions just in the one chain. In the cost of one on-chain transaction is like less than 1 cent. All these transactions which resolvers execute, they are secured by the collateral. So that means, for example, if user wanna like swap, let's say in simple mode, 100 USDC. So the collateral 140 USDC. So it's like a 40% more. And this is the institution program for liquidators. So if the resolver fail intent, they can start a new competition. And because this is an on-chain transaction, it can be done just one time. So they will start to do it as soon as possible. And that's how we can demotivate resolvers to make a fail of transaction and create an incentivized program for liquidators. Right now in the Kinetics, we're planning to scale in L2 networks. We are focusing on L2 networks for Bitcoin and Ethereum. Probably in the next 2 months, we will add most of the popular networks. And also we are open a gateway for the projects. So if you have your project and you're looking for like a TVL, or you need to attract new users from the different chains, so you can easily use our API and use our infrastructure like any kind of combination of intents which resolver will solve. Like a few days ago, we already launched in the mainnet. Right now it's the limit with 500. Soon it will be 1,000 and more. And for example, we already done like integration with Gnosis Pay. So you can easily move your Bitcoin native or any other asset from any chain directly to Euro E just in one click. And you don't need to store a gas. And you can delegate this to the resolver who will like launch it and do all the actions on the back end. Soon we will open public resolving. So all the resolvers, they can join. And we don't require like any stake for this, so it will be open and public. As a result, we can see here execution time is a few blocks because there is no intermediaries, so we don't need to pay for validators in the process of execution. So if the user asks resolver to make an intent and the resolver completed in time, we don't need to pay any intermediaries and we don't need to wait for them. The same situation with the gas cost. So usually when you do combination of DEXs and bridges, your gas will cost around like 600-700. So, but we get as a result like 65K gas units just for one on-chain transaction. So 2 on-chain transactions around like 130K. And the same situation with the rates, because we don't have intermediaries like a pools, and we don't have a formula which isolate inside the ecosystem. So resolvers, they can provide higher amounts than one because they can do arbitrage strategy and they can also do a rebalancing strategy. We're planning to use a token for decentralized system. So it's like similar to POWs when you spend your electricity to update the state of the ZK Lite clients. And also we will use it for decentralized matching. So there's all the like match of the orders from the resolvers will be state on the nodes of our stakeholders. We're already live. If you will need to move your assets instantly with without any fee and with a cheap gas, so all you will need to use the API, contact me. I will happy to answer on all your questions.
But how are we going to solve the liquidity fragmentation problem? For example, I want to get around 10 millions on mode network. And your solver could have, like one solver have a 500K and another 1 million, and that's all. Because how it could be done in more way to really fulfill the order, not to wait until the bridges could work and so on to deliver liquidity. Because currently what we found in Gearbox that the lack of liquidity on the many L2 networks create a huge barrier, and even liquidators, for example, who want to liquidate such big positions are in trouble, and it could be solved, I believe, with intent.
If we talk about the biggest amount, like millions and 100 millions, we have solution, but it's not in the current version. So the current version is more like adoption of intents. And our focus is to create a gateway possibility to use the projects with a framework and not build all the multi-chain infrastructure. But we're thinking about this problem for a long time, and we have also a solution. This solution will be in the next version. So it will be like a chain abstraction, multi-chain pool with like stable coins. So when you can it will be not a trading pair. So it will be like a liquidity which you can use for the borrowing mechanism, and you can solve a higher amount. So you don't need to split like order every time when you have like 1 million between all the resolvers. But you can use this liquidity in the borrow and lending protocol. Thank you.
All right. Okay, that was loud. Yeah, well, thanks everybody for being here. Going to be talking about this idea of crypto as the sort of like picks and shovels for AI, something you probably heard around in the narrative a little bit, and I want to try to flesh it out and poke at it and discuss it a little bit. If you don't know me, I'm Matt Stevenson. I'm the head of research at Pantera. A little bit about my background. I guess I have research partner here. I don't know which is the more prestigious sounding title, so I'm just trying to impress you, give you both shots, just in case. I'm an econ PhD at Columbia, mostly micro, kind of a game theory approach. I've been in crypto since 2011 is like the cool story, but I've actually been in research crypto only since 2017. ETH Research, a company called Block Science, which is at least kind of familiar more generally in the city, and you might know of it. And then I've done some early writings that, I think have been reasonably insightful about the way things would go, right? So I wrote about blockchains as commitment devices back in the day in 2017, DeSci, RPGF. ML for asset abstraction in 2021 with my colleague Zargam. So to brag on myself a little bit, I think I generally will get to things early and say semi-credible things about them. So hopefully we're going to try to do that today. And that's my Twitter because I usually forget to give it. So I'm mainly coming to you today with a sort of extension of this 2023 paper with some colleagues, with Barnaby and Tomas and Shin and Jonathan and Davide. That we got to present at the AI conference, NeurIPS last year, on cooperative AI via decentralized commitment devices. So the essential angle here is that there's a future in which there are autonomous agents and they transact on chain and they utilize commitment to solve coordination problems, right? And I think we give a pretty robust reason why that would be so. The AI folks bought it, at least the ones we talked to or talked to us. In the TLDR, from a kind of game theory way is basically if you train AIs in this computationally efficient way, which is called external regret minimization, you wind up with an equilibrium that's like not quite non-cooperative. It's not robust to strategic deviations is the idea. What does that look like? It looks like MEV. And so that connection is pretty robust. And the idea that the intuition that it goes to MEV is about right, we think. And so that's the TLDR of that paper. What I'd like to do this talk is extend it and generalize it a little bit. So in particular, that one is about a particular type of like multi-agent reinforcement learning. We did that as an example case. But I want to talk about it in a more kind of realistic case, right? Like what we basically have now is we have these two types of models. We'll talk about this in a minute, right? We have transformers and we have diffusion models, which just kind of appeared on the scene. And those are interesting, but they weren't specifically addressed in our paper. And then I'd like to sort of explore the way those markets might develop and how those might map to different possible futures. So we're going to have to do a little tiny bit of something that feels a little like futurism, which I'm pretty uncomfortable with. Like as an academic, it's like the line is like it's always hard enough to predict the past or whatever. But I'm going to do my best here, okay? And then lastly, we're going to talk about this MEV concept a little more in detail as well, right? So we're going to talk about this specifically as being demand incompatibility from a multi-agent future. So why I'm uncomfortable with futurism? There is a tradition of VC futurism, right, where you basically take the set of things you invested in recently, and then you try to map them onto the union of the set of like the podcast you heard recently, and then like the two big sci-fi novels you read or whatever, right? And so like that's usually the way you kind of do futurism here. Gonna not do that here. But I'm mindful of that tradition, so I'm going to try to not stray from it. Instead, let's try to like look at what we have and be a little theoretically grounded. So I said, right, we have two models. They just sort of appeared on the scene. We have a transformer model and we have a diffusion model or an architecture, however you want to say it, right? To my eyes, they didn't appear exceptionally different or better than any other architecture that was proposed, except they happened to work. Don't take it from me, the guy who taught me ML a little bit. David Bly, he said the same thing. He's like, if I show you it on a whiteboard, there's nothing about it that's going to be especially interesting to you, right, compared to any other model. It just so happens that these things work in a really interesting way. They show high returns to data, they show high returns to compute, and they seem to do these just useful things. That seems obvious, so that's baseline. But that gives us three sources of uncertainty. And to be like good futurists here, let's try to walk through them with a little bit of logic, right? We have uncertainty about like, I don't know, what if a new architecture drops from the sky? That's one possibility, right? Like just happened to us last year, or actually several years ago, right? But we understood it last year. And then there's more compute and more data, right? Which is the sort of like you hang around OpenAI or whatever. That's practically the motto, right? More compute, more data, more compute, more data. They show great returns to both compute and data. So we have uncertainties around how those production functions essentially wind up playing out. So when we talk about these futures, I'm gonna give you like two broad bucket cases, right? One is just this kind of like AGI, ASI, like what is money even mean, man, sort of future. And if we go there, I'm not going to try to talk about it because like I don't think you can predict anything in that future. I'm not going to try to predict what crypto AI is going to be, right? So whenever we go there, I don't know. I'll see you guys in the paperclip maximizer or in our great utopia or whatever it is. But then otherwise, I'm just basically going to say probably we wind up with crypto as picks and shovels. Now, I keep promising that. I'm going to try to deliver on it. It just takes some stage setting, right? So the first path is new architectures. I have no idea what that's going to be. That just goes right to AI utopia. What does that money even mean, man? I don't know, right? Can't really predict that. So we're going to kind of skip that one and just say, well, it seems like we probably only got two that kind of do what we think is especially useful. So I don't know what our probability or our expectation is on this, but I'm skipping it. But now let's talk about returns to compute, right? So let's say returns to compute are like stepwise crazy great, and we have some new crazy thing that's in front of us once we have the new NVIDIA chip or whatever. Well, that's probably, again, our Shoggoth utopia, whatever it is. But in the more realistic case, where just the returns maybe, let's say, continue to be high or even diminish, I think you start to get some market segmentation. Basically, you get what we call in the industry here monopolistic competition, right? Where some people are maybe competing over the high end, right? You're constantly buying the new chip. You're trying to compete on the cutting edge of computation. But for the consumers and other cases, they're happy with a little less, right? So the idea is this is called like satisficing. You can think about it like TVs or something, right? Yes, there's always newer and better and more high-res TVs LTVs, but the pace at which people consume them, right? They start to get kind of happy with what they have. It's like things can only be so HD, even if you could make fewer and fewer pixels, right? So in that case, I think you get diffusion. And again, I'm sort of like pushing this diffusion to the crypto picks and shovels argument. Second, we have returns to data, right? If it's the case that returns to data are really high, right, then again, we're in AI utopia. But if it follows some reasonable functional form, right, then we probably start to get market segmentation too. Some companies which can capture data and really, really improve their models may win. That becomes maybe a little unique and different because it's kind of oligopolistic. Maybe it turns out that the prompts you input are really important inputs to the next model, which gives you this kind of like positive feedback loop. That probably tends toward monopoly or oligopoly on some level, on the model level. But I think, again, we can probably imagine that there's still this satisficing element where some people are happy with the cheaper or more differentiated or more specialized product, in which case we at least have some kicking over to this consumer diffusion picks and shovels argument. This is the whole map, just, I don't know, proof of work here. And so I said, now I've got to justify why a blockchain. What I really just gave you is why consumer diffusion, right? Why a blockchain? So I think if you hang around crypto Twitter, you'll kind of get some flavor of like, crypto is like 24/7, always on, super battle tested, financial rails, it's programmable money. I'll disagree with that, by the way. I think that's not essentially an incorrect take, right? But it's kind of the 101, and it's a little hand wavy, we might say, right? I think the programmable money part winds up being the especially interesting part of that, in my view, because it isn't clear to me why you couldn't do banking 24/7, always on, right? Like, it doesn't seem absolutely impossible that you could never outcompete, right, on that front. It just happens to be the way banking is done today, let's say. So the more advanced one from my esteemed co-author, Davide, he gave a talk last month. He did a nice sort of like, here's why blockchains are an ideal substrate. I'd encourage you to watch his talk at Stanford last month at Erica's Open Source AI Summit. But I'm going to do a sort of specialized version here. I'm going to focus on a particular sort of area of commitments and demand, right? And the reason I do it is my kind of motto is, as a researcher in the space, is if you want to solve a problem, you try to identify the small toy game that the problem essentially is, and then you solve it based on that game. So I was trained as a game theorist, so that's essentially what I do. And what is the toy game, or what is the model? I mean, we're basically trying to look at an agent-based future, right? Like, specifically in the paper, we're looking at this particular use case of you have an AI agent that's maybe, let's say, gonna do your bidding. And so what is the game? What is the toy game we're modeling? Well, that's what we're gonna try to do. Like, what does it look like if you and I have two different competing agents, right? And what happens if we have some objective and they compete on that objective? Well, I'm gonna argue that the demand version of it kind of looks like this. It's going to be a coordination game. That's pretty typical, right? So you have a bottle of wine. You have two patrons with incompatible demands, right? Each one, let's say, wants the whole bottle, right? And then let's say you have two agents tasked to, I don't know, go out to the store and get you one, or send a message for it to be delivered, or whatever it is, right? We should talk a little bit about what it means for the demands to be incompatible. You each want the bottle of wine, but let's say you would actually you'd strictly prefer, right, half a bottle to nothing or whatever, right? You'd like some wine at the very least. And so what this is going to do is it's going to create this kind of like continuum of equilibria where what we'd really just like is the bottle of wine. And so the problem, and I'm going to show you the model in a second, is what happens when our demands are incompatible, when we both send the signal that we both want the whole bottle of wine, right? Like, those are just incompatible demands. The world can't meet those. And that's just to cheat and give you give you a little info ahead. That's the kind of MEV-ish side. If that sounds like MEV, no surprise, right? This is the real-world MEV piece. So what does the game theory sort of toy model version of this look like? This is a really discrete, simplified version of the coordination game. You could actually just sort of draw it as a line, right, with multiple equilibria. But it looks like this. We're just going to say you have three things you'd like to get out of the wine, right? Like, you could do a low demand, a medium demand, and a high demand. You'd say high is like, I want most of the bottle. Mediums, I want half. Lows, I want 1/3, right? And then it just so happens when we both send that signal, if they're compatible, we each get our demand. And if they're incompatible, we're going to say we both get 0. You can say whatever that is, right? Like, maybe we pay a penalty. Maybe we just we're frustrated by no wine because couldn't be our interest couldn't be served, maybe we just have to send something again, right? Depends on how we want to think about the sort of failure mode of this, but we're just going to call that 0 and the worst outcome. And so if you just follow the logic, right, it's obvious. If we both request half a bottle of wine, we can do that, right? If I request high and you request low, we can do that, and so on, right? But you can also see that if we both request low, we can do that too. We just leave a little bit on the table. And so what I bolded here is like the Pareto frontier, right? The idea that we're each doing as well as we possibly could and getting as much wine as we possibly could. And that's where we'd like to live. So this part is almost silly because it's so straightforward, but I think this is essentially the right way to talk about it, which is if you allow one of these two parties in the wine to have a commitment device, right? Which is basically to commit upfront to their demand, then you wind up with the equilibrium that they can sort of enforce, right? So they get to enforce the equilibrium they like, right? If I don't get this, then I penalize myself in some way, thus you know I'm really going to try to do it. Or if I don't get this, then I'm going to penalize you in some way, right? Like anything that looks like a commitment, a conditional commitment, right? Such that if this doesn't go through, then X bad thing will happen that changes these particular payoffs, means that I get to enforce the equilibrium of my choosing, right? I always get high. Probably shouldn't say it that way. I always get the high payoff. So, right, and of course this is crude and discrete, right? In actuality, you'd get everything but epsilon, right? Because you just have to offer somebody else the minimum so that they agree. So if this is the case, then you just want to deviate to commitment, right? Of course, I'd love to have a commitment device. And this is, sometimes you'll read this as like commitment races or something like that, right? Well, if that's the case, if somebody's going to be better off if they go for a commitment and they're going to get everything but epsilon, I might like to have a commitment structure too. So the idea is just, I would like to go to a decentralized commitment device, which is essentially a blockchain, right? You get to program these commitments. You get to program however you want to model the commitment game theoretically, right? Whether it's self-slashing, whether it's other slashing, whether it's something like that, right? You can credibly commit and you can send the message to somebody else and you could enforce this equilibrium, which means somebody else wants to do it too. And when you I skipped the slide, or I have the slide hidden here. But it turns out, you can trust me on this, that if you smooth the function slightly and you give both people access to commitment, they wind up pretty close to the 50-50. That's where it usually winds up going. Basically has to do with how bad it is when you get really, really far away, right? When you really, when you're a special sort of uncertainty that happens when you're close to demanding it all, right? So here's what we've sort of covered as the futurism part, right? We have this idea that AI tech is going to inevitably diffuse, decentralize, and so on, right? We've decided, or I've contended, that decentralized AI agents are useful. I didn't spend a lot of time defending that one. Hopefully it's in the air enough that that seems to be true. OpenAI is doing a lot in this. I can sort of feel to me that it would be very useful. So I sort of took that as given. And then we have this game theory part, which basically says, if there's some competing resource that you're both after, then you're better off deviating to commitment, right? And then whatever it becomes, whether it becomes like a Stackelberg game or whether you want to think of it as like a bargaining game or whatever, you can wind up with different outcomes, but essentially the model is going to be around the same, right? And so that would have agents transacting on decentralized commitment devices because it's just incentive compatible if they both want to do it. I don't think I've proven that. I've just sort of like gestured toward it in what I think is a pretty plausible way. And then again, the specific outcome of how these things work out depends on your model, and I honestly don't think there's an answer, is my genuine opinion. But I think the answer would live on a blockchain. At any rate, that is going to be my talk. I'm going to finish a little bit early just so I can save room for questions if there are any. If anybody wants to just bail and go to the party, I understand that too. I'm happy to talk outside. So thank you very much. Cool. Good. Any questions? We good? Awesome. All right. Well, thanks for staying. If you have any, you can catch me outside. All right.